Our facilitator is supposed to take us today, which is Mr. Olarewaju Samson, but unfortunately he's on transit, so he won't be joining us. But then he said he will be available for the night class, the 9 p.m. class. So after attending this class, and you might want to grab something more, we'll attend the night class. So it's going to be more or less like a discussion of what we've done this morning. Okay. So on that note, I will go ahead to share my screen so that.
Hello, sir.
Hello, good morning.
Good morning, sir.
Yeah.
Sorry, please. The night class, is it for today, please?
Yes, it's going to be for today for those that couldn't join this one.
Okay.
Yeah.
Thank you, sir.
Okay. So can we see the screen?
Yes, sir. We can see it, sir.
Yes, sir.
Okay. So our presentation outline today is going to be, design calculation for cable sizing. And sorry, okay, I need to make Ken a host, so co-host, so we can able to help me to admit people coming in. I'm seeing two Ken here. Ken, which one are you?
I'm here.
Okay. Okay, I've seen it. So making you a co-host, so you help me to admit the one. So we are going to be looking at basic calculation for cable sizing, design calculation for AC and DC breaker and their sizes, then design calculation for battery field and breaker size, then battery charge time calculation and battery backup time calculation. So these last two are like part of what we did with Mr. Lai on the other class, where we looked at the size of battery we need for a particular system, and how much the battery is going to run. Then he went ahead to look at the DOD again. So today, let's start from cable sizing. Just like I mentioned earlier, I said, after knowing that, okay, this client needs this amount of energy, and the inverter size I'm going to, design for him, the number of panel, the number of the capacity of battery. So today now we are going to be looking at what size of cable are you going to use after you have gotten all this right. Because believe it or not, the way the major components are important, the smaller components too are important. I hope we remember the major and minor components we discuss in system components, right?
Yes, sir.
Okay, so I'll take that so far we've gotten all the things we need the way we're proceeding from it, right? Is there anybody that is, lagging behind, or that doesn't know how to identify a battery or inverter, or that can't say that, okay, if I have solar panel now, I have inverter, I have battery, that he doesn't know how to connect these three things together? So that we can just brush it up again. Just like I said, we are not paying for this class. So the only thing you need to pay is attention. Ken, people are waiting in their waiting room. So please, you know,
Okay, this is my
Okay,
time
okay.
of joining, so I don't have idea on it.
The first time you're joining the class, well, I think you should be looking at, you know, going back to the recordings and probably join the next phase of the lecture again, the next phase of the training. Why these ones stick to their, leadership training, you have to start with, or depend on your experience though. Have you had experience with anything relating to solar, how this whole thing works?
I have experience on it. I have little experience on it, but not it just hints like I'm not perfect on it yet.
Okay, so when you define hints, what do you
You
mean
see?
by so when you say hints, what are you looking at? What do you mean by hints? Like, I want to know, do you know do you know what the work of inverter? What the inverter does in the whole overall system?
Um,
Just tell
not really,
me,
but
just
no,
tell
no,
it
no.
to me the way you understand it.
Okay, I know what the charge controller is used to. It's used for charging up the battery. Then they have different types of charge controller from 30 amps to 120 amps
That is the
in Philips.
sizes, not the types.
Sorry, they have the sizes. Then the types they have MPPT and PPT.
MPPT and PWM.
Yes,
Okay,
PWM in the charge controller.
okay,
Then coming to the battery, they have wet cell, dry cell, which is the tubular battery, and the lithium battery, which is the highest.
okay,
Then the inverters, they have ranges of inverters starting from 900 and something kVA to
900, 900 VA.
yes, to 10 kVA, and they also have what are they calling it? Hybrid and transformer base.
So,
Hybrid is the one that has charge controller, while transformer base doesn't have charge controller, and it's strong. Like the lifespan is stronger than the hybrid in some cases. Ehen.
okay, let me
Then
tell you that's a myth. It's not real. Just know it. For
is
the
it?
fact it's not real. For the fact that it's non-hybrid doesn't make it more stronger than hybrids. Okay?
Yeah, but there's disadvantage in case when there is a breakdown, maybe the thunder affected one, you'll still be using. Let's say if you are using,
If thunder affects your inverter, your charge controller will not do anything for you because your charge controller is a DC-DC converter. It doesn't
you
produce C current.
but you can use it direct sun like in the afternoon. You can use it direct from the sun during the afternoon.
You can't
Then
except you have a DC bulb. Charge controller does
DC
not
board.
charge controller does not produce light. It's a DC-DC
Oh,
converter. The only time that charge controller can produce light for you is if it is a DC load you are putting on it. Maybe you have a DC fridge, which is very rare, or you
Obi
have
Dala.
a DC bulb, which is common in some cases, or maybe any other DC load. But charge controllers doesn't give out AC current. So let's not go on that because Big Sun still have other trainings that are coming up. So hopefully, if we stick around a little, more time, and then we are going to have an, overall recap of what we've done, because the essence is not for, for us to train you and then you pass out and we'll give you certificate. No, you are not. It's not the certification that is the cost of the training. The cost of the training is for you to actually know what it is. Okay, why we brought this program in the first place is for us to help grow the solar industry. Okay, reducing people that don't have idea of what installing solar looks like. So That is the idea. The idea is not to have many people that have graduated and offer them certificates. You come and take pictures and then everybody go home. No. The essence is for us to really do the work because the quacks are jeopardizing the solar industry. Okay? People are losing interest. So what we'll do is make sure we train enough people that go out spreading the good news by installing reliable systems so that if your next neighbor has been enjoying the system for 4 years, 5 years, and is saving cost, you too will want to go, right? You want to go solar. So that is the essence, making solar to be more adaptable for a lot of people. Even someone who doesn't have money, he will want to do solar. And inshallah, as time goes on, we are going to have a credit, a situation where we are going to have all our installers that are practicing and actively working. We'll have a product and a system where you can, actively engage your clients and install for them on a pay option, pay later option at a very subsidized rate, not what they are doing currently. Because right now, somebody will tell you, yeah, there is a pay later option, but then you are going to pay as high as 3%, 3% per month. If you're looking at 3% per month in 1 year, that's 36%. It's a whole lot of money. So we are looking for a way to, reduce all these things by bringing together a pool of people that knows what they are doing, and then UN is capable of doing a whole lot of things. So the essence is for us to really know this and continue on the course of not just making money for ourselves but saving the time. Because more people that use generators, the more pollution we'll have and a whole lot of that. So when you're on your leadership training, you learn more of how your actions affect the system and how you being a solar installer helps to mitigate it. So let's proceed. So today, our learning objective is that at the end of this module, trainees should be able to, size the solar power system properly, be able to properly size the cables for solar installation, be able to properly size AC and DC circuit breakers. Okay? So when I say AC and DC circuit breakers, we understand what that means, right? There is AC circuits and then there is DC circuits. You understand what DC and AC means, right? Then determine, battery backup time, then determine solar panel charge time. Okay. So when you have 6 panels to charge 2 batteries, how much time, are you going to use to do that? So cable sizing. So cable sizing depends on many factors, such as maximum current carrying capacity. What this means is maximum current carrying capacity is how much current can this, particular of cable carry. Okay, we should have a minimum voltage drop and have a minimum, resistive loss. As the cables will be placed in the outdoor environment, it should be water resistant and ultraviolet, resistant. Like, there are some cables. Let me not say you might have seen because some of us have not been to site, but there are cables that are written TUC. Okay, temperature and ultraviolet, control. It's more or less like a 2-layer cable. So all these things, we don't read these things. So focus on the read things. So we can read up these things. Okay. So we are going to start with calculating cable size. So when you're calculating cable size, you're going to be looking at what we call VDI, voltage drop index method for calculating cable size. That's VDI. Okay. Are we together?
Yes, sir. Yes, sir. We are together.
So at this point, we are going to be doing calculations. So I will need us to, bring out our jotter or our writing material because we're going to be calculating things right now. We're going to be doing some calculations. So I don't want a situation whereby some people are calculating while some are not. If you want to speak and it's not related to what we're doing, kindly mute your mic. We've gone over this. right?
Oh,
Joshua, Mr. Joshua, good morning. Please mute your mic, except you want to talk to us.
I'm muted, please. I'm muted. So sorry.
Thank you, sir. How are you?
I'm good. I'm good. Sorry, I'm at work. So sorry, please.
No, no problem. That's fine. Okay, so are we ready to proceed with our writing material ready?
Yes, sir.
Hello,
Yes.
sir. Hello, sir. Can
Yes,
you please move to the show the previous slide, please, sir?
the picture,
Yes, the previous slide. Previous slide.
the cable sizing.
Yes, yeah, yes, sir.
Okay,
We want
so
to
are
complete
we
some.
ready with our,
Okay, sir. We can move on.
okay, so are we ready to calculate right now?
Yes, sir.
Okay, does
We are
somebody
good
know
to go.
the distance of a one-story building from the roof down to, to the floor? Does anybody have an idea? Okay, let's just assume that one-story building is about let's say 15 meters. Okay, because of some places you might pass before you get to your inverter room. Okay, are we good?
Yes, sir. We can hear you very well. We're okay.
Okay, so let's take that. Then we are looking at voltage drop index method of calculating cable size. So voltage VDI is not VDM because before some people start writing something else. To hear VD now, some people just quickly add M. So what we are looking at is VDI, okay, voltage drop index. And voltage drop index, VDI, is equal to what? Solar panel current, that is amps. So when we are looking at solar panel current, we are looking at the what? The IIC, okay? Then times one-way distance. That is the distance of the distance at which the cable is going to travel. If it's a one-story building, let's say it's 15 meters, we calculate 15 meters, okay? So, but then we are not going to be using meter to do this calculation. We are going to be using feet, okay? So, in a situation where we have meter, we need to, convert it to feet, okay? So that we won't have errors in our calculation. Are we ready to proceed?
Yes, sir.
Okay. Okay, so then times one-way distance, then over what? Output voltage times 2. So output voltage is the overall voltage of the panel. So when you calculate your panels in series, when you connect your panels in series, the overall voltage is going to be higher than when put when you connect your panels in parallel. We all understand that, right?
Yeah.
Okay. So when I say we all understand it, I expect people to say something so I'll know you are with us, not just one person. Okay?
Yeah, I follow you.
Sir, we are with you. The only thing is you always want to be very attentive while you're doing it so that at least there won't be interruption. Thank you.
I cannot be attentive while
Yes, we are with you.
if you are not attentive and I'm being attentive, I know it. I'm trying to
We
let
are
you know it.
following. We are
So it's
following.
you
We are
I
that
following.
refer to
need to
us.
be
I refer to
attentive.
us, not you, sir. I mean, we want to be attentive so that we can get everything that you're doing.
Okay. But then if you are being attentive, I need to know you are following me because I'm not seeing you.
Yes,
Okay?
we are. We are, sir. We are. Carry on, sir.
Okay, so now let's take this first example. Okay. So we have using 5 pieces of solar modules or solar panel with the following specification. The VOC is 49.5, the ISC is 10.1 amps, and then the power is 500 watts. So this VOC and ISC is what? is the data sheet from a 500 watt panel. Okay. Now, determine the size of cable required to connect the panels to the charge controller over a distance of 100 feet. Okay. This 100 feet is roughly about 30 meters. But let's be working with feet because that is the, the there is this thing we call it in physics where you are going to have Chrysogonus, can you remind me? I think
Is it the dimension or what SI mean?
yeah, dimension. Yeah. In dimension, you do a lot of conversion from this to that, and then this one is equal to this. So every formula has the corresponding SI units or dimensions that they use for the calculation to make it accurate. So let's proceed. Okay. We already know the formula for VDI. So what are we looking at? See, distance between solar panel and charge controller is 100 feet, right? Now, we are going to do two things, okay? And these two things is going to be dependent on our charge controller or hybrid inverter, okay? So, system voltage, since we are connecting panels in series, okay? This is just an assumption, okay? If your
Okay, sir.
if your panels are in series, then you are going to have total voltage, that is VT, okay? It's going to be V1 plus V2 plus V3 plus V4 plus V5, which means it's 49.5 in 5 places. So when we point that in a calculator, we are going to have a total voltage of what? 247.5 volts, okay? So the total voltage is what? 247.5 volts. Then the panel current is ISA, okay, times 1.3 or 1.2 as the case may be. We know where 1.2 is coming from, right? Or 1.3. Safety or factor, right?
Yes, still remember. Yes.
Yeah, good. So, which means that solar panel current is going to be 13.13, okay? Then, and the voltage is going to be what? 247.5. So, apply the formula.
Please, back slide, please. The previous slide. Sorry.
Okay.
Okay, the IAC in this case, okay, 10.1. Okay,
Yeah.
10.1. Okay, times
Yeah.
1.3. Okay, it's fine.
Okay.
Thank you.
All right. So, so let's apply this formula, right? So VDI is equal to panel current, right? And panel current is 13.13, right? Then times the
No,
distance
sir,
of
are you
what?
back? Please, sir, I've not written the previous slide. I'm here to show it, sir.
Okay.
Okay.
The previous
Okay,
slide,
sir.
we are just like getting the, when you want to calculate something, you get every other thing set.
Okay.
Like
Yes, sir.
we are working with solar panel arms, then the distance, and even this distance was given to us in meters. We are supposed to convert it to feet, right? So
To fit.
these are things
Yes, sir.
that to have our.
Hello, sir. I say we are getting this. We are getting the slide after the class now.
Yes, we are. Yeah,
Just,
just like
because of my brother that he keeps saying that we should go back, so that at least.
okay. So
So
we'll
I
do
just
the.
Okay, so that you can move forward quickly.
yes,
Yeah,
let's just proceed
I want
because of
this
time.
today's
Thank you.
class to be as quick as possible. Okay.
All right,
Then
sir.
okay. So
Okay, sir. Thank you, sir.
what is just there is this. The formula for VDI is going to be solar panel amps, which you have gotten to be what? 13.13, right? Times what? Our one-way distance is going to be what? What they gave us in the example was what? 100 feet, right?
100 feet.
Then all over what?
It is 50 meter.
The total voltage, solar panel total voltage, okay? Times 2, okay? So our total voltage is 247.5 times 2, right? Which is going to give us what? 495. Okay? So
Please, question.
Okay.
Is a bit confusing. What are we multiplying by 2? Is it the voltage?
Total voltage, the total solar panel total voltage. Then you are multiplying it by 2. That is the formula.
Okay, is that this equation is as good as saying what the solar panel amps times the distance of the panel to charge controller, then all divided by voltage times 2, right?
Yes, total voltage times 2. Yes.
Okay. I was thinking it's only the one-way distance
Is it total arms?
Not the
a single arm.
Solar panel arms, the single arms. That's there. The total arms, of course, the total arms or the total voltage. Yes. So
Okay.
it's going to be dependent on how you connected your panel. So when we look at this, right, we are going to look at how
the other.
Yeah, we'll look at the other way around. So
okay, sir.
So when we multiply this, we are going to have our VDI to be 2.6, which is approximately 3. Okay, because you don't have 2.6 VDI. Okay. Are we together?
Yes, sir. We are with you.
Yeah.
We are
sorry,
together.
the 2 is it for 2 days?
No, now, like we are looking at how to calculate cable size using voltage drop index method. Okay, which is called VDI.
So we have different methods. So this is one.
Yes.
Yeah. My question is just the 2. What does the 2 represent?
So the 2 represents what we call VDI, the voltage drop index.
Okay.
Now, where the thing comes in this way is like this. VDI is voltage drop index. Now, there is a chart that shows the voltage drop index in relation to VDI and then MM. And
it's like a constant.
Yeah? It's not a constant. Yes, it's like a constant in the sense that 3 VDI is equal to 12, AWD. AWG is American gauge wire or American wire gauge. So sometimes you call it AGW, or I think this is a mistake for my. It's supposed to be AWG, American wire gauge.
Maybe can I also add something?
Okay.
I was thinking when you mean by VDA3, it is the same as 3 millimeter squared, which is the standard way of measuring wire. Would I still be making some sense?
No. VDI is a kind of should I say is a parameter for measuring something, for measuring cable.
Oh,
okay. I said if you are not saying something that is relating to our class, please mute your mic so that
please mute your mic. It's interrupting us.
Yes, because I was thinking normally wires, when we buy them, especially here in Kenya, we normally use millimeter squared. I don't know how we can be able to get...
Wait now, Moses, wait. That is where we are going right now.
Okay. Yes, thank you. Asante.
All right. So there is a chart that where you have your VDI, then you have your AWG, and then you have your square, millimeter square. Because here in Nigeria too, our wire size are measured in millimeter square. Okay.
Good. True.
Okay.
Yes.
So we said that 3 VDI is equivalent to 12 AWG. Okay. You can either choose 12 AWG wire or higher cable. Okay, but you don't choose something less. Now, wire meter, that's the sizes of wire inside. So this is like the conversion. Okay, this is the chart of VDI against AWG. Okay, are we getting it?
Yes. Very clear.
Yes. Yes.
Let me check if I have. Okay, yeah. So we are going to make use of these two charts as we proceed. So our VDI is what? 3, right? And 3 is equivalent to what? 12 AWG, right?
Yes.
Yeah, 12.
Now, in this place, AWG to mm square, we are having 12 AWG, right?
Yes.
Yes.
Which is
That
equal
is
to what?
equivalent to 4 mm wire.
To 4 mm.
Exactly.
4.0.
Yeah, 4 mm. Understand? So when you calculate your cable voltage drop index now, when you get your VDI now, and is 3 or this or that, then you're going to convert it to AWG, and from AWG, we now know the mm that it is in our local distance, because we are not in America, right?
Okay.
So
You get it, sir.
it's very clear now, right?
Yes,
sir.
yes. Very clear now.
Okay. So I want us to go back to this place. Now, I want us to calculate this same. Earlier I mentioned that your cable sizing or your connection type is going to be dependent on your charge controller or your hybrid inverter, right? I made mention of that.
Yes.
Okay.
Yes, sir.
Now, I want us to, we've gotten that in this connection, when we have the 5 panels in series, we will need 4 mm, Abi.
Yes, sir.
So, us to put these 5 panels in series, in parallel. Okay. So we'll see if we still need the same cable. And when we get the cable, we'll now look at what? How the charge controller too, how it comes in. Okay, how it affects the charge controller or your hybrid inverter. So let's proceed. So if we are connecting this panel in parallel, somebody should take us on this. What are we going to do? How are we going to get our total voltage? What's going to be our total voltage? What's going to be our total panel current? Somebody should do it, not Chrysogonus.
Now, total panel, sir.
Yes.
Total panel harms
The
will be
total voltage of the
50,
panel. Okay, sorry, somebody saying.
50.5.
Let's start with the voltage. Voltage is 49.5.
Yes, sir.
While the current
is
is
it the total
10.1.
voltage?
Sir, the total voltage will be 49.5. Since we are connecting in parallel, the voltage will remain
No,
the
in
same.
series.
9.5, right?
We are connecting in series, no parallel.
No, the one
We
we
are
did the
connected.
other time is series.
We did series before.
We are
Sir?
So
considering
series that we
parallel.
did before.
Yes, it was series we did before now, where we,
Yes,
let
yes,
the
we are
Yes.
moving to the
voltage.
Yes, so
parallel.
we are
now
doing
we
it
want to
parallel
connect
now.
it in parallel. So
So in parallel, sir, 49.5 volts will be our total voltage, sir.
okay,
Why
stop it there. No, stop it there. Somebody else should take from there.
No. Sir, if it is going to be in parallel, you multiply 49.5 by the number of panel, which is 49.5 times 5. That will give us the total voltage.
But
Then the
now,
current.
no. You are mistaken.
No. Sorry.
That's why
The voltage. Sorry. I'm getting it wrong. Sorry.
The
Is the
current
current
is 65.65.
by 5, while the voltage remain the same.
The
Exactly.
current is 65.65. 65.65 current.
Okay, total current is what? 65?
65.65. 65.65. 65.65.
Did you when you got the total current, did you multiply it by the safety of factor, which is 1.3?
Yes, I did 10.1 times 5, then times 1.3.
Okay, good.
Someone else can also confirm. Someone else to confirm.
Yes, you're correct.
65.65.
Okay, 65 point. So, and we are working with our normal distance, right? Which is 100.
Yes, 100.
So let's apply this on our formula. Okay, so our VDI now is going to be equal to the total solar panel current, right? Is what? 65.65, right? Times 100 feet, right?
Yes, that is correct.
Okay. All over what? 49.5 times
49.5 times 2.
Okay. So when we did that,
Yes.
what is the 65.65 times 100 going to give us?
That will give us 65, 65.
6, 5,
65.
6.
Times 100.
65.
That okay, 6,565,
605.
right? 6,565. 6,565, right?
Yes.
Okay. All over what? 49.5 times 2.
99.
98.4.
49.5
No.
times 2 is going to give us 99.
99. So
Okay.
we are going to get 66.31.
So 6,565 divided by 99 is going to give
That
us
is
what?
66.31. 66.31.
66.31, right?
Yes.
So that's our VDI.
We go to the table now.
Okay, so let's go to table. So, sorry. So our VDI, we have what? 66.3, right? And
Yes.
we don't have 66 here. So we'll go for the
6. We
higher
only
one.
have 62, 78. 78.
Yes.
We are going to go to 78, right?
Yeah, 78.
Okay, so 78 is going to be 3 over 0 AWG, right?
Yes,
Yes.
sir.
Yes, sir.
Okay, so 3 over 0 AWG is what? In millimeter?
95 mm.
95
95.
mm.
95 mm, right?
Yes.
Okay.
Yes.
Okay, so now the first one we did, we got 4 mm, right?
Yes, sir.
Yes.
Connecting the same panel again in a different way, we now got what? 95 mm.
Yes.
Now, even if somebody who doesn't know, who has not been to the market to buy cable, if you are designing a system, okay, let's not go to the economic, importance here. Let's look at how it affects our charge controller. Okay. Now we have, what is the total partner current we have is what? 65.65, right? Now, do you know that in our first calculation, if you have a panel that is 500 volts, yeah, by 500 volts, maybe 80 amps or 60 amps, yeah, it can take the first one, right?
Yes.
Are we together?
Yes, sir.
Yes, we are.
Together.
I want us to calm down. There is something I want us to understand here. Okay? Kenny, are you doing your job? I'm seeing people at the waiting room. Okay?
Okay.
So let's take a chill pill. Let's calm down. I want us to look at things properly here. There is something I wanted us to look at, but I will see how I can bring it in. Okay? So the first one, we have, higher voltage and low current, right? Now, I want us to do one thing. Somebody should, try get us the formula for resistance. Okay? We know what resistance is, right?
Yes.
The opposition to the flow of current.
V equal to IR.
V equal to what? IR.
R equals to V over current.
Which means that R is equal to V over I, right?
Yeah.
Okay. So I want us to look at these two method of connection. In the first one, our V is equal to what? 247.5, right? And our I is equal to 13.13, which means that our R is going to be what? Somebody should calculate now. 247.5, Abi, divide by what? 13.13. Our resistance is going to be 18.
18.9 approximately.
Boom.
Or Abi, okay, 18.9 or 18.4, 18.8, sorry. Okay, now this is our resistance in the first one. Let's look at our resistance in the second one. Okay, our voltage in the first one is what? 49.5, right? All over what? 65.65.
0.75.
0.5.
753.
Sorry, just you guys should give me. Hello, sir. Yes, I'm in class. So send me a message by 12.
Okay. Yeah, I don't know when I was going to give my just take one call. I don't know how your schedule be for that whatever we do for next site.
Okay.
You need
So give me a moment. Hello.
Yeah, we are here.
So I want us sorry about that. So I was trying to let us look at. So what we got was 0.7, right? As the resistance,
Yes.
right? Okay. Now in these two, I'm trying to figure out something here. this resistance, is it V over I or I over V? I'm trying to guess it because it's been a while I did this chat thing.
Is V
Resistance
over I.
is equal to V over I. V over I.
V over I, right?
Yes.
Okay. So I want to, get the, because what I'm trying to let us understand here is this. When you have higher voltage, when you have higher voltage, the resistance to the flow of current is going to be very low. But what we are calculating here is different. So I'm trying to find the chart that explains what I'm trying to say. When you connect panels in series, the resistance that is applied to it, the opposition to the flow of current that is applied to it is lower than when you connect your panels in parallel. So I'm trying to let us see the relationship. There is a chart that explains what I'm trying to let us understand.
Hello.
Okay.
Can I make a contribution?
Okay, so what I'm trying to look at is this. So before I say what I want to say, what are you trying to contribute?
Okay. I think the relationship between the current and voltage holds when we have a constant resistance or resistance per se.
Exactly. That's what I just figured right now. Because what I want to let us see is that the relationship between current and resistance, because they have an inverse relationship. Because I is equal to V over R. You understand? So
Yeah.
when you look at it from this way, you now find out that if our R is equal to 0.7, then if we are looking at now the current is now going to be the voltage of the panel over the resistance. Understand? So the resistance is going to affect it less when the current is higher. That was just what I'm trying to let us see here. Just that I don't get the chart in the first place. Okay? So the relationship between the current and the resistance is an inverse relationship, which means if resistance is higher, the current is going to be affected more. Okay, so let's put it in this our calculation.
I can also add, when you check out that formula, I is equals to V over R.
Exactly.
So that is the one we should be using now. I is equals to V over R.
Now, we've gotten the two resistance, just like we calculated. The first one is 18.84, right? Our first R, when we connect it in series, right? And when we connect it in parallel, our resistance is 0.7, right? 75, are we? 74. Right? So I
Yes,
want
sir.
us to look at how it affects the current. So when you connect your panels in series, our voltage was what? 247.5, right? And our resistance is 18.84. So if you are looking at it, our current is going to be around 247.5 divided by 18.84. Our current is going to be 13.13. Okay. So the essence, what I'm just trying to put it like, there is this way that our facilitator, okay, yeah. Let me use the example that he gave. He said that you should look at a tank, okay? You should take the solar panel as a tank, okay? Now, the cable as a host that you are using to take water from that tank, right? To how should I put it? The cable is going to be the host that you are going to use to take water from the tank to where you are taking the water to. And then our current is going to be the water. So then the resistance is like kind of a knot on the, I've forgotten how he narrated this, but the essence, what is the idea is this. Why is my voice?
Hello, sir. Can I give my own contribution, sir?
Just let me finish. Okay. Okay. All right. The whole overall idea is this: when you have more current, you tend to have more resistance, and also the more distance you have. We all know that distance affects DC cables. That's established, right? So what we are trying to do here is this: to let you understand that when you connect your panels in series, when you have a higher voltage, the chances of the resistance affecting it is lower than when you have more current. So current affects, resistance affects current more than it affects voltage. That is just the idea. Okay? So most times you're connecting your panels over a distance, you try as much as possible to, have a higher voltage other than, higher current. And also try as much as possible to reduce the distance if, we have the opportunity. Okay, so somebody said you wanted to make a contribution. Hello? Someone said you wanted to say something. Or if you we can proceed if I'm not contributing.
Yeah, hello, sir.
Yes, I'm with you.
I didn't know I've not unmuted. I didn't know I have not unmuted the mic. Yeah, it is based on what you're trying to say. We could remember during our institution, our power teacher will always tell us that just like the way you're explaining that if you have a tap, then the pressure that brings out the water, just like the hose, as you're saying, is the voltage. So the bigger, the larger the pipe, that's the larger. The larger the pipe, the high amount of voltage that can push that water, and the smaller the pipe, the smaller how the current can come out. That's just exactly what you explained now. If we have a very higher voltage, meaning that the current can be pushed on time, and if it is a small pipe, then the voltage can be small. So that's the idea. I thought that I said, okay, I want to contribute. I think if it can help us get it right, sir.
To
Thank you.
understand what we're trying to say. Okay.
Yes, sir.
That simply means pressure is resistance, sir. Abi?
Yeah.
No, the pressure is the voltage. The pressure is the voltage.
No,
and the pipe is just
when you have a smaller pipe, you will need higher force to be able to push the wire. But if the pipe is a little bigger, you don't need that much effort for the water to, accelerate.
Now,
Okay?
sir, to get this clearly now, what can we use to donate the resistance on a simple term to a layman? Resistance. I think
So
it's
just
the
see
one
resistance
given
as,
something here.
I think it can be the mouth now. How bigger the mouth of the pipe is. So if you have a smaller pipe, if you have a high pressure, it will not come out.
Okay, let's say the control point.
Can I say something?
okay, Chrysogonus.
Yeah.
Okay.
Okay. Now, to explain resistance to a layman like the young guy requested. Okay. Now, imagine a river or a stream flowing. Okay. First of all, voltage is kind of a force that pushes current. Understand? Voltage is the force that pushes current. Understand? So, assuming a river now flowing, possibly flowing, let's say descending, in a descending form, maybe coming down, not coming down from somewhere, from the source, you understand? From the source, which is the source is kind of the grid or wherever. It's coming down from there. And it's traveling the river is traveling, maybe the river from Lagos to Ibadan, understand? So the force, which is the voltage flowing, controlling the current is the C waves. Those waves you are seeing that is moving. That's the current. Then the resistance can be said to be maybe the obstacles that are seen on the river. Possibly maybe a log of wood fell. You understand? And it blocked somewhere. So the water will now hit, instead of the water flowing easily through to wherever to its destination, that log of wood that fell on the river has now caused an obstruction. So it's now a resistance to the flow of the water, or
Yeah.
resistance as in the case of electricity. I don't know if you get.
Yes, so you are
Okay.
understand that. So what we are trying to just establish is the fact that resistance is an opposition to the flow of current, which means that for you to have a lower or a smaller resistance, you need to have a higher voltage. Okay, so when you have higher voltage, this resistance is low, and then the diameter of the cable also matters, because if, just like you use the river to, the part of the river, if it's a narrow part and then there is a log of wood around it, you know that since the voltage is pushing the water wave, right, and there is a log of wood on that part which is small, then you know that the water is going to find a way to maneuver it. So
And the resistance
as
will
it's
be high.
as the resistance is there. So if it's trying to maneuver it and then the part at which the water is flowing is not wide enough, then you see that there is going to be a reduction in the other side of which the water is flowing into. Then the water will be forced to you know uh be held back at the base, or find a way to diffract around the
That
object.
that finding a way can be possibly a spark or an explosion, as the case may be.
Or
Assuming now is assuming
or
assuming
the part is now congested, so it's going to cause the cable to be heating up. So if in
to
this
be
case we
hitting
are
up here.
talking about cable, so is either it start heating up, and know when it starts to heat up, it starts shrinking and then start burning. So, but what I want us to just understand the idea is this: for you to avoid resistance, you need to have a higher voltage and less current. That is just the understand, because resistance and current have an inverse relationship. They don't like each other. If this one is going this way, this one is going this way. So as much as you can try to avoid having a higher current, because when you have higher current, resistance is going to come for you. Okay, are we with that? So let's look at cable size, calculating wire size for inverter to battery. Before we continue with this, I want to say that on standard base, on standard condition, the average size or the standard size between your inverter and your battery should not be more than 3 meters. It shouldn't be more than 3 meters. Okay, so try to reduce your distance between your cable and your inverter to be maybe 1 meter, or because okay, let's just calculate it so you understand it, so it wouldn't be as if I'm the one that said it. Because it's a DC current or DC voltage, as the case may be. So distance is going to, affect it. Okay, so let's look at this connection. Okay, so let's use the following example of cable from battery to inverter. Okay, so in this case now we have a battery that is 12 volts, 100 amps, and then we'll have an inverter that is 12 volts, 1000 amps. Okay, so let's take our distance to be 3 meters. Okay, between the inverter and the battery. Okay, so this 3 meter is equivalent to what? Does somebody have a formula for converting meter to feet?
Almost 6 feet.
Meter to feet. A feet is about 3 meters.
3 meters, I think. Yeah. 1 feet.
Yeah.
No.
So 100 feet.
1 meter is about 3 feet, bro.
Yes.
1 meter is 3 feet.
Yeah.
1 meter is 3 feet. Sorry.
So it's 6 feet, 9 feet.
So this is going to be 9 feet, right?
Yeah.
Okay. So and since is one battery and okay, let's just make this to be a little, tricky. Okay. Let's say that our battery is 4. Okay. We have 4 pieces of 12 volts, 100 amps. Okay. Are we good? So if we have 4 pieces of 12 volts, 100 amps, how are we going to first of all connect our battery? Somebody should tell me that.
Okay, sir. Hello, sir.
Abdulaziz, not you. Somebody else. I need somebody else. I need to know that we are not just 3 or 4 people in this class that is following what we're doing. Somebody else should tell us how we are going to connect this 4 battery of 12 volts, 100 amps to a 12 volt inverter that is 1000.
Okay. Let me talk, sir.
Okay. Hello, can I say something?
Hello, sir.
Let this other guy say something. Adeni, what's that his name?
Adeyemo.
Yeah, Adeyemo. Yeah.
Okay. If you want to use 4 batteries for a 12 volt inverter.
Yes.
So we will connect the 4 batteries in parallel. That is, all the positive will be connected together and all the negative also be connected together.
Okay.
So now connect it to the inverter.
How many people agree with him?
I agree. If
he's connecting parallel, then I agree, sir.
I agree, sir, because the inverter must see all the 4 batteries as one.
But the fact is, for the fact the inverter is 12 volts, the voltage of the battery needs to remain the same. So it has to be connected in parallel. So I keep it constant.
Somebody said that he did not agree.
Somebody said he did not agree.
Who said that, sir?
Okay, I did not agree because the inverter is 12 volts, right?
Yes.
And the batteries are 12 volts each. So your battery connection should not exceed the voltage of the inverter. So from what they taught us, if you connect in parallel, if you connect Hey, I agree though. Jesus Christ.
Hey, commission.
Connect in parallel.
Actually,
I don't make you land.
So we
Connect in
connect in
parallel.
parallel.
The
That
voltage is
is
constant
12 volts,
and the
400 amps.
current increase.
You know, do you know
Correct
the,
in
do
series.
you know
Can I say
the
something as well?
yes, Mutin.
Okay. So, the first person said that we are going to connect in parallel. Yes, that's how we do it. To connect in parallel because there are 12 volts and this inverter is 12 volts. But one thing about the charging now, the AC charging or this thing will now affect because of 12 before battery. It will slow down the charging rates. The battery will not, the peak at which it will charge will not be as fast like that
Yeah,
because
I get
what's
that. But
supposed to
what we are trying to achieve in this currently right now is just how the battery will be connected. Then knowing if our connection
okay,
will
the battery will be
change
connected
or
parallel.
the charge time or the efficiency of the system, let that come later. Let's just look at the connection first.
Okay,
Establish that.
okay, sir. Parallel that
So we have all agreed that
earlier.
the four batteries are going to be in parallel, right?
Yes, sir.
Okay. So, and you say that the distance between them we are using 3 meters, right? So, if we are connecting this battery in parallel, that means we are going to have 12 volts, right, as our total voltage, right? Are we together?
Yes, sir.
Yes, sir. We are
Yes,
with
sir.
you, sir.
12 volt, 400 amps hour.
Okay.
You
And
said,
then
sir.
100 is going to be 100 times 4, right? Which is
Yes, sir.
400 amps hour.
Okay. So in this case now, if we are going to get our VDI, what we are going to do is VDI is going to be what? The current. So we are not looking at panel now, we're looking at battery. So it's going to be what? The battery current, which is what? 400, right?
Yes, sir.
Okay. Times what?
Times.
We are going to have to times this 400 by the safety of factor first, right?
Yes.
Which is 1.3. So what's that going to give us? 400 times 1.3 is going to give us what?
Only one, only, sir.
520 amps, right?
Yes.
Okay. So applying our formula, we have 520 amps times what? Are we forgetting our
520
formula?
times 9 feet.
Times 9 feet. All over what? Our voltage is 12, Abi? Times 2.
Yes. 12
So we
times
are going
12.
to have 520 times 9, which is going to give us 4,680 all over 24, right? Are we together?
Yes, sir.
Yes.
Which is what? 195 VDI. So our VDI is 195. Is somebody confused on how we got this? Hello? I assume that the silence means that nobody is confused, right?
Yes, sir.
Okay, so
sorry. Hello, sir.
Joshua.
Yes, please. I said I'm at work. I'm only listening, and I believe the PDF. I will go through since it has to do with calculations. I think there are issues I will go back. I'm on call.
Joshua, should we go on?
Oh, yes, sir. Yes, sir. Yes.
Yes, sir. Please.
Yes, sir.
Sikiru.
I haven't got the formula.
You haven't got the formula of VDI that we have been using?
Yes, sir.
But you have the formula of VDM.
No.
You know, get formula VDM. Formula for VDM. Let's now give. If you don't have VDM, then let's give you VDI. So we said that VDI is equal to what? Solar panel cable or
Solar panel amps times one-way distance over output voltage times 2.
Good.
Total output voltage.
Yeah, total output voltage. The voltage that you have calculated, whether in series or in parallel. That's why they say total. So either way you are connecting, the total of your connection is what you are going to use.
Solar panel cable times
One-way distance. That's the distance from where you
distance.
are taking, where what you are connecting is going to the end point, either from your battery to your inverter or from your solar panel to your hybrid inverter or charge controller. Moses, you cannot be calling me on this line.
times.
Divided by output voltage times 2.
Moses.
Okay.
Send me a message. I'm on call. Send me a message. So
okay.
Are we good? Secret, are we together now?
Yes, I've gotten the VDI now.
Okay. So don't go for VDM since you have VDI. Okay. This one. Sorry, please. Moses, what's up? I say send me a message. Send me a message. I'm using this thing for my you are not even in class. God help you. Sorry. So now we've gotten our VDI. Okay. So let's go back to the chart. Okay. So our VDI is 195, right? And we don't have 195. Okay. So let's just say our VDI is 99. Okay. Which is 4 over 0.
4 over 0, 120 mm.
120. So are we getting the idea of these things? Wherever we are having, low voltage, we will require very, insane amount of to buy. Imagine you are designing a 4 battery system for your client and you are buying 120 cable.
But sir, can I ask a question, sir?
Effect.
Can I ask a question, sir?
Yes.
Yes, sir. Sorry. All these like a chart or table, or what will I say it? How do you know all these things off earth to know the exact that we are going to get?
Okay, so you can, I not say, it's just like somebody, one of teachers then, he say you are going to mathematics class or mathematics exam, don't carry your 4-figure table. How do you want to do it? And you are not carrying calculator. Of course, you have to have this chart somewhere on your laptop. So as you are doing your design, you are seeing it. You understand? You can't have this in your head. I don't have it.
Okay, sir. Thank you, sir.
I beg, at this my old age, my brain cannot even retain something like when we are cramming things in primary school and secondary school.
And also, please, never you assume in anything. Never you assume anything. Always confirm.
When you assume things, we've looked at the effect of when we assume things on sites. There is no shortcut to things. You just make sure you are working on the right, make sure that everything is right. Because believe it or not, when you are confused on sites, your client knows. If you are working on site and at some point you get confused, your clients
psychological.
Yes, they will know because your reaction. Okay, so aside that, are we saying that once we have low voltage, you will need a higher cable meters for us to do our connection. So you are doing 4 battery system and you are buying 120 mm. It doesn't make any sense, right? So generally, we've seen that for you to have, very economic and efficient system, you should always try to, amplify your voltage. So let's look at this example again. If our inverter is a 48-volt system. Okay? Are we together?
Yes, sir.
So after this
Yes, sir.
example, we are moving to another thing. We are not looking at cable again. Okay? So let's pay attention and then get this correctly. Okay? So if we assume that our inverter is a 48-volt, even though there is no 48-volt that is 1000 watts, you can't have a 1 kV inverter that is 48-volt. Okay? Though we can have 2.5 that is 48-volt, but it's very rare. I've seen Outback that is 2.5. But Outback inverter is something I don't even think there's an office you can buy it here in Nigeria. 2 places where I've seen it decline voltage from US and come down here. Those are kind of, American spec of inverters that are just too rugged. They have like, it's a 2.5 kVA, but you can load 5 kVA on it. It's more or less like Vitron. They can have like 120, 130, like times 2 of their threshold. And they work at almost 99.9% efficient. So let's look at this. So somebody should take us on this to ensure that all of us we are together. Okay, secure.
Yes, sir.
Sorry, I have to call your name. So take us on this. Help us to get our cable size using voltage drop index, VDI, on 4 batteries of 12 volts, 100 amps. Okay, being connected to a 48-volt inverter. Okay, and the distance between the inverter and the battery bank is 3 meters.
Okay.
So help us to get our VDI. So you'll be our lecturer now. So let's follow you. If there's something you need us to calculate, you calculate, we'll calculate. So every other person too, pay attention and do it while he's doing it with us. So let's proceed.
Okay. So our solar panel cable, we are using a 120 mm. So multiply by the distance, which is 3. That's 360.
So you said our solar panel cable, we are working at 4 battery that is 12 volts, 100 amps, and we are connecting it to a 48-volt inverter. And we want to connect the batteries in series. So the 4 batteries are going to be in series, yes. So what are we going to have as our VDI? What's going to be our cable size?
Okay. Yes, sir. Already this is series. Our cable size will be 55 mm.
65 mm.
Yes, sir.
How do you get that?
On the charts.
Do you know your VDI already?
VDI? No.
If you don't know your VDI, how then did you get that is 65 mm?
From the formula you gave to me, for the VDI, the cable times the distance over the output voltage.
Okay.
Of the panel.
Oh yeah, now walk us through it like you are taking us on it. You are teaching us on it. So our voltage is going to be, what is going to be our total voltage? Our VT is what? Our total voltage is what?
Let me calculate this. So over 48. So we have 7.5 volt.
Our voltage, total voltage is what?
7.5 volts.
7.5 volts.
Yes, sir. Using VDI formula.
How now? No, I want us to get the parameters before we calculate the VDI. So for us to use, voltage drop index, we need to have our total voltage, right? Our distance and our current.
Voltage.
Hmm?
Our currents.
Yeah.
I'm lost. So.
Sorry, TQ, can you state the formula for VDI again?
Yes, sir.
Or yeah, tell me the formula.
Solar panel cable size multiplied by the distance of the cable.
Not solar panel cable size. Solar panel current or your battery current, anyone you are calculating. Solar panel current, okay? Total current,
Okay.
yes. Your total current times your distance, your one-way
Okay.
distance, okay?
Yes, sir.
All over total voltage times 2.
Total voltage times 2. Oh,
Yes.
okay.
So you've gotten the formula, right?
Yes, sir.
Okay, now apply this formula to this our question we are trying to solve now. So let's have our VDI. Let's take it step by step. Abdulaziz, please mute yourself.
Okay, sir.
Thanks.
So the battery currents, the current passing through the battery now.
Mm-hmm.
So you have 48 volts for batteries. Let's say 40 amps.
40 amps. Did you get the
Yes.
question? Our question is this. We are trying to connect 4 batteries, 4 pieces of battery, right? And each battery is 12 volts, 100 amps. Okay? And
Okay.
these 4 batteries, we are connecting it to a 48 volt inverter. So automatically, you know that the batteries are going to be in series.
Yes, sir.
Okay. So if you know that your batteries are going to be in series, then
yes, sir.
apply this to our formula of VDI to get our VDI. Then we can convert our VDI to mm and know the size of our cable that we are going to use to connect this battery to the inverter.
Okay. I don't know the current passing through the cable now. The battery currents now.
The battery current is 100 amps now.
Oh, aha. 100 amps. So we have
Are you
using
writing
the
what we are
formula
saying
now.
down? Are you
I'm
writing it
writing
down?
it. Yes, sir.
Okay, good. So,
So our amps now we have 100 amps.
okay.
This is the current multiplied by the distance, which is 3 meters.
Okay. And we say that when we are using VDI, what is the SI unit we are using for distance?
That's feet.
Feet. So 3 meters is how many feet?
That's 9 feet.
Okay. So are we timing it by 3 or by 9?
By 3.
Why?
Oh. We should be using 9.
Okay.
3 times 3 will give us 9.
Okay.
So our total voltage, which is 48 volts, multiplied by 2.
Okay.
So let me use my calculator to get the final answer.
Are you not forgetting something? When we are
No.
calculating our current, we will have what we call safety or factor. You think you are omitting it.
Oh. So what should we use for that? For
Safety or
the
factor
safety?
is 1.2, 1.3, sorry.
1.3. It will multiply everything together.
You are going to be having your current multiplied by 1.3, then times the one-way distance. You have to have your total current first, right? Before you multiply further. But then it's cumulative. So
Okay. So 100 times 9. 900. divided by 6. So our numerator is 100 times 9, which is 900, all over our denominator 48 times 2, which is 96. 900 divided by 96 will give us 9.38 approximately. So we will now multiply it by our safety now, which is 1.3.
Okay. No, keep going. Just tell us your final answer.
Final answer equals to 12.19 approximately.
Okay.
So that's my final answer.
Okay. Somebody else, does anybody have a contrary opinion?
Our final answer is we are using 4 mm, sir.
No, let's start from the VDI first.
Okay, the video, okay. 100, which is 100 amps times, we are removing the units now. 100 times 9 times 1.3, that's the safety factor. Over 48 times 2. So we are having 1,170 over 96, which will give us 12.1875. So approximately is 12. So
That's the
our
12.2.
AWG is 12.
12.2, right? So our VDI is 12.2, right?
Yes, sir. Let's say 12.2, sir. Yes, sir.
Okay, Sikiru, what is your VDI?
VDI 12.1.
You said?
12.1 now.
7.1.
12.19.
12.19. Okay. So we are all on the same page, right?
Yes, sir.
So if our VDI is 12.1, so when we have 12 in VDI, the next one is 20. So we can either use this 12. You are seeing my cursor, right? We can either use this 12 or 20. Okay. So let's say we are using 6. So 12.1, Abi?
Yes, sir. 12.2.
Okay. So let's say we are using 6 AWG. Okay.
Okay.
Somebody is interfering with us. So
that's Chrysogonus. Please, if you can mute your mic.
What is going on? Chrysogonus.
Please, I want to attend to something.
Chrysogonus, what are you doing?
Hello, sir. You can as well unmute him by yourself, sir.
Okay. So let's proceed, right? Are we together? Sorry for that. Are we together? Or I've muted everybody? No.
No, we are with you, sir. We are with you.
We are with you, sir.
Okay, so our VDI was 12.1, right? Which is equivalent to 6 AWG.
12.2.
Right?
Yes, sir.
12.2.
Yes, sir.
So this 6 AWG or 12, which is going to be 4, between these two. So we either use what? 16 mm or 25 mm.
25 mm.
Right? Which is, reasonable, right? Because when we did this calculation before on the 12-volt system, we are requiring more than 120 mm of cable. Right?
Yes, sir.
So
yes,
the
sir.
more voltage you have, the lesser mm we are going to have. Because less current, less resistance. So that. Sikiru, can you mute yourself? I said when you are not saying something that is relating to our class, mute yourself.
Oh, I'm sorry,
Okay?
sir.
I can't go to and be meeting everybody one by one. It's not doesn't make sense. We are all mature. We are all adults. Right? Okay.
Yes, sir. Let's proceed, sir.
All right. Okay, so we've looked at cable, right? Okay. So we've looked at this our calculation, right? So now we are going to be, let's look at what we have next, like the breaker size. Okay?
Sorry, I need a little clarification on the cable stuff.
Okay, tell me what you need.
Okay, like the cable sizes we are calculating with the cable sizes we have been calculating, is it like the size for two strands, that's for positive and negative, or for just a strand? I don't know whether I get what I'm saying.
No,
The
it's going
question.
to be, you cannot have you cannot go and connect a cable where you are using your positive is 25 mm and your negative is 6 mm. No, now.
Like my question is, in a situation whereby after calculation we have a 25 mm square as our cable gauge, so we are getting 225 mm for the positive and negative, right?
Yes, now you are calculating your like one-way distance. Yes, now use positive and negative. I mean, is it only negative we are using to the circuit will not be complete now? It's for the entire connection, positive and negative. Because it's not advisable, even as much as we think that the negative doesn't carry much load. You need it to complete your circuit because electrons flow from cathode to anode, right?
Yes.
Yes, sir. It's the returning part, sir.
Yeah, two of them has to be the same size.
Okay, no problem.
Yeah. So let's look at our breaker sizes now. Trying to take us to size of DC circuit breaker. Okay, so I want us to understand that this safety of factor thing, it can be either way. Some people use 1.25, some people use 1.3, some people even use 1.5, but that's on the higher side. But it's always between this 1.2, 1.25 to 1.3. So it's not like in some case you now have to say, okay, we use 1.2 here. If you use either 1.2, from 1.2 to 1.3 is, you are safe. Okay, so let's look at size of circuit breaker. Okay, which is equal to what? Solar panel power times 1.5 all over solar panel voltage. That's solar panel power. Okay, then times safety of factor all over what? The solar panel voltage. So the solar panel voltage is the overall connection. You understand? Are we ready to proceed?
Sir, the solar panel voltage, is it the system?
Yes, sir, we are with you.
The system voltage, yes, your connection voltage.
Okay. Not the VOC, sir.
No, not the VOC.
Okay, sir. Okay, I understand now.
Okay. So,
wait, I have something to say.
Chrysogonus, I'm not happy with you. What is going on? We are in class, you didn't unmute yourself, and then you are saying something that I don't know. Everybody is
Sorry,
complaining.
sorry, I forgot to buy my boss. I'm sorry about that.
No.
It was a mistake. It was a mistake. I never done it before.
What
Sorry.
do you have to say? Let's proceed.
Okay, just like a question. This voltage you're talking about, is it total output voltage from the
Yes,
panel?
the total output voltage of your connection, yes.
Of your connection from the panel, right? Like
Yes,
from the
yes.
the one you got from the meter. Like
The system, sir. System, not
System, okay,
connection.
let's put
System.
it
Maybe you are going
on
for
system
12
voltage.
volt
So
system.
when you connect
Or
your panels in parallel, the overall voltage you got is what you are going to use for your calculation. Then when you
not
connect
the
panels in series, the overall voltage you got, that's what you're going to use for your calculation.
okay, because by system voltage, I think you mean the voltage of the inverter. That's why I'm asking.
No, not the system voltage. The overall, the total output voltage now.
Okay.
So that,
I can verify.
Yeah. So the idea is if you are connecting in series, you have a different breaker size you are going to use. If you are connecting in parallel, you have a different breaker size you're going to use. Okay. Okay.
So
So
sir,
let's.
sorry, sir. Let me quickly chip in something. So somebody asked about is it the VOC or this or the VMP? You said it's the like according to your words, like you are saying it's the VMP. But I just want to chip in something. Due to my own experience on this job as well, there are some panels. So, though sometimes you do get sticker panels, and there are even some panels that they even stated their VOC. But when during the sunshine, rain period, some panel used to shoot up even above their VOC. I've witnessed that before.
That is why
So sometimes
if you look at the panel, there is always a plus or minus 5%.
Yes, sir.
Yes.
So that's why I'm saying maybe if you just consider the VOC to be on a more safer side.
We are not talking about VMP here. We are always working with VOC.
No, somebody asked that if it is the VOC, I think you negated that.
No. I said it's not the VOC. Like what I mean is not okay. I got what you're saying now. What I mean is not the VOC doesn't mean it's the VMP. What I mean by is not the VOC is that the voltage you are going to be looking at is not the VOC, like the individual VOC of the panel. The voltage we are going to be looking at is the total voltage of your connection.
Yes, okay.
The sum of all the VOCs after the connection.
Not the VOC, yes.
Let me
most of this.
Okay, let me just put it.
Material.
It's the VOC you are going to be calculating but not like if we have 5 panels and the VOC of one is 49, then you are going to say that your total voltage is 49. No, it has to be dependent on either you are connecting them in series or in parallel. Is that clear?
Yes, sir. That is clear, sir.
Okay, so let's proceed. Okay. All right. So this slide, it seems I omitted some things, but while we are proceeding, I can make some correction. So our example, we say a PV array has a capacity of 2,500 watt power and a and a voltage output of 247.5. Determine the appropriate DC breaker for the system. Okay, so we are going to be looking at the PV array, which we say that on our formula for DC breaker size is the total panel power. Okay, so they gave us the total panel power to be what? 2,500 watt. Okay.
Yes, sir.
And the total output power is 247.5. So it's a very straightforward. This my data is even tearing up. Looking for a place to write. Okay, so if you are looking at our DC breaker size, we are going to be looking at what is the total power is what 2,500 watt times our safety of factor, which is 1.25, all over the total, the system, the output voltage, which is 247.5 volts. What's that going to give us?
Sir.
Yes.
What if we connect using series connection, sir?
Wait, now we are coming to that.
Using parallel, sir.
Wait, now we are coming. After we got this, I'm going to break it down so that we'll see what is behind the question.
Okay, sir.
Yeah. So can we calculate this one now?
Okay,
2,500 watts times 1.25 all over
divided by 4 over 2. It's going to give us 2.6.
12.6.
going to give us 12.6, right?
12. Yes, sir.
12.6 amps, right?
Yes, sir.
Yes, sir.
So the DC breaker you need for this is 12.6 amps, right? Now, I want us to look at the behind the scene of the question. Okay? Okay? Because in real life, the question is not going to come like this. In real life, what you are going to be having is I have 9 panels of 560 watts. Okay? So what is going to be the breaker size? That is how the question is going to come in real life, right?
Okay,
Are we
sir.
together?
Yes, sir.
Yes, sir.
Okay. So if you have 9, let's start from the obvious. Okay. So if you have 9 pieces of 560 watt panel, to you to get your total power, you have to have to times 560 watts times 9, Abi?
Times 9. Yes, sir.
Which is what? 5,000.
Which is 5,040.
5,040, right?
Yes,
sir.
Now, your total power, you have 9 panels, right?
Yes, sir.
So let's assume now that
We should unlock this.
560 watt panel.
Yes, sir.
560 watt panel, the VOC now of your panel is going to be between 49. Okay, let's just say we are using 50.5 as our VOC. Okay? Which means one panel is the VOC is what? Let's say 51.5. There is nothing like 50.5. 51.5. Okay? Because when you bring out your panel, you are going to see the VOC behind it now. So in this case, because we are not working with any panel on site, we are assuming that the individual voltage of that 560 watt panel we are working with is 51.5. Okay?
Yeah, but you know, sizing is what you do before you go to site. So how do we know this thing without
Before we
seeing
get to
the
site,
panel?
so how you are going to you don't know the VOC of the
Most of
panel
these
you are
things when
buying
you are
to
sourcing
your
for your
design?
panels.
Why you are sourcing for your panel in your design?
Yes,
You should know that okay, I'm working with
you should
560
know
watts.
that
You be
on
able
the
to see
average,
the VOC now.
most of these are panels, aside from exhausted also that used to have a 60 VOC. Most of
Get
them
my
are
point.
between
Get
45,
my point. Get my
51.
point. Get my point. Not
I get your
not for
point.
me though.
I
Not
get
for
your
me though.
point.
Like
But
for
for
example
every
now.
design you are going to do, for every design you are going to do, you have to know your panel VOC, VMP, ISC, and VMP. I mean
My,
IMP.
my question is now, you know, but when you're doing this sizing now, you are doing it at home. You've not seen the panel before. So
That's
how
what
do
I'm
you get the
saying, that you have to know the panel that is available in the market
okay?
while you are doing your design. We know when we talked about battery and inverter, we did some calculation that resulted to our 24 volts and 300 watts, which we said that is not available in the market. So
Yes,
you have
sir.
to, your design is based on what is available.
Unamdi,
Yes, sir.
hello, Unamdi. Sorry.
Yes.
I want to talk to the last person that spoke. See, a lot of times, the mistake some people make is that you do some things based on assumption. For every one design that I have done in the past, what I do, I look for the available panel, I look for their data sheets. Everything you want is on the data sheets.
Exactly.
So as an installer, as a solar designer, you need to make sure that you have your data sheets while you are designing.
You
Thank you.
start designing. Okay, so I hope that is established, right?
Yeah.
Okay, so let's now, proceed. We have 9 panels, right? And of 560 watts. And this 9 panel, we're assuming that the VOC of each one is 51.5. So there are two things. If you are working with a hybrid inverter that is maybe 500 volts, right? You can have your whole 9 panels in series, right? Or you can decide to have your panels 3 in series. These are the 2 options available for this kind of connection, right? Or the third option is to have the whole 9 panel in parallel, which is like, oh my God, how on earth? Understand? So let's take the 2 option, or probably the 3 option, and see what comes out of it. So let's assume we are having our 9 panels in series. So we are going to be having 51.5, right?
Yes, sir.
Times 9, right?
463.5.
463.5.
5. Yes, sir.
Which means we are going to be having what?
10.8 or 10.9.
Sorry, just a minute. Hello? Hello? No, he did not. So let me finish this class. I will call him. Okay, so we are going to be having our total power, which is 5,040, right? Times 1.25 first, which is going to give us what? 5,040 times 1.25 is going to give us what? 6,300, right? All over our total voltage, which is 463.5, right? It's going to give us what? 463.5. Going to give us 13.59, which is like 13.6, right? Are we together? Did everybody get the same answer as I did?
Yes, sir.
Okay. Are we together?
13.6. Yes, sir. 13.6. Approximately 13.6.
Yeah. Okay. Okay. So that's that. If we are connecting the whole panels in series, right?
Yes, sir.
Okay. So when we are connecting the panels in, let's say, 3 in series, okay? So let's take it. Our total power is going to be, when we times our total power, our total power is still the same, whether we are connecting them, the whole panels in series or, doing in series. The total power is the same. We all understand this.
6,300.
Yeah? Which is 6,300, right?
Sir.
Are we getting it? Hello?
Hello, sir.
Yeah, are we together?
Yes, sir. Yes, sir.
There are some people that we have 33 participants. I'm just hearing the voice of 3 or 4 people.
I'm with you, sir. 3 now, 51.3 times 3 is
Yeah, no, I
154.
need to know that every other person is
We are
here.
with you, sir. We are with you.
No,
Yeah,
I
we are,
don't.
we
I
are
don't.
following. We are with you, sir.
We are here, sir.
We
We
are,
are,
we are all ears. We are
we are
hearing
doing
you.
the
We are hearing
calculations
you.
ourselves too, sir.
Prosper, are you here?
I'm with you, sir. I'm with you, sir.
Everybody is doing the calculations, sir. We are here with you.
Christian Innocent.
I'm here. I'm here.
I'm on the road, so I don't want to, to unmute my mic because of the noise.
Yeah, I
But I'm with
understand,
you.
but I need to be sure that this Agbaje Kehinde, are you with us? You see, some people are not with us. Dada Maria.
No, I'm with you. Agbaje Kehinde is with you. 10.6 approximately. I'm getting it. I'm doing the calculation with you. I'm here. I'm just quiet.
Samuel is with you, sir. Andrea Samuel is with you.
Okay.
So I think
Agbaje Kehinde, we
majority
are
of
all
them are
with you, sir.
just
Yes,
here
sir.
with
We
with you,
just
us.
don't
sir.
want it to be rowdy. Yes, sir.
Yeah, I understand. But I need to. The essence is
Yeah.
for all of us to, understand it. You understand? Not just some people. I want all of us to, unanimously understand it, so that when we are taking the recap before we proceed, we will be able to, ensure that okay, if this person is giving something to design, because in as much as this is free, you are going to have exams. Okay, and the exams are going to be like real life scenarios. We are not teaching you these things for you to come and do like a university exam. It's real life questions, things that we've talked about and how we go about things and all that. Okay,
Yes, sir.
and you need to also pay attention to the little theory things, because after your leadership program, you are going to be taking current exam. So you are going to be a certified solar engineer, like current certified. Okay, and we are paying for it. That one is still free. Okay, so I need to be sure that I'm not registering 40 people, 35 people for an exam that we are going to be paying almost 100K for each person, and I'm not certain that we are like maybe 80-90% to pass. Okay, so we need to demonstrate that we have what it takes before we can proceed with the current exam. And current is, the theory there is more or less like 30%. It's practical and then oral. They will ask you questions. When I went to take my current exam, the guy was asking me, let me tell you this question the guy asked me. The guy looked at me, he said, you are confident. When I want to go and do my practical, I said I should not worry. That I look very confident. That I looks like I know. Okay, if he first of all asked me, have I been practicing? I said yes. So he said I shouldn't bother with the practical. One question he asked me is this. Apart from the fact that he asked me, why is my name Namdi Abdullahi? Because literally everywhere I go, somebody will always ask me, why are you Namdi Abdullahi? And I will keep on answering. So apart from that, the second question he asked me was, a restaurant owner in the Southwest, who is running his restaurant as a side business and only uses his power from 9 a.m. in the morning till 11, and then he closes and go to his other business. Where will he put his solar panels? I say he will put the solar panels on his roof facing south. He said, but he's going to be from 9 a.m. in the morning to 11 a.m. Yes, I said yes. That even if you want to use the panel for 2 hours, it's still in the south. Understand? So even if you know what you are doing, they need to be sure that you have the confidence so that you don't go to site and somebody convince you otherwise, because there are some things that some of our technicians used to do. I've seen where somebody, I think I've said it here before, I've seen where somebody is using changeover to change between lithium battery and tubular battery on one inverter. Changeover, knife switch, 100 amps for that matter. That is not even copper, because this one they will tell you is copper. I lie. Like, I'm sure that guy probably knows what he's doing for him to even think of changeover. But why will a client convince you otherwise for what you know that is a technical blunder because you want to collect the money? Yes, you probably need the money, but do the right thing. There are situations if the client still wants to use his old tubular batteries or dry cell battery and is getting a new lithium battery, ask him to buy 2 inverter. So he can be switching between one inverter and the next, not be switching between 2 battery in one distance. Nah, it's very dangerous. Very, very dangerous. Maybe when Albert take you on, hacking, when two battery terminals meet, if you see what it does to people, I think one of my people, one of my boys, if I go and start looking for it, his tying battery, in inverter, the positive and negative are literally in the same plate. So he's tightening this one, then he now go and carry, while he has already put the positive and he's tying the negative, then as he's bending the spanner like this, the thing go and touch the other one. Even despite that he's wearing hand glove, the thing tear the thing come out. The spanner almost cut it into 2. So when you are not being careful, or when you try not to know what you're doing on site, it's very dangerous, both to you, the system, and the environment. So you try to be careful. Okay. So let's proceed. Okay. So we know where we are, right? Our total power is 6,300 after you have times it by the safety of factor, right? So now we are looking at connecting the panels 3 in series. So what's going to be our system voltage now? Going to be 5.2, right? 5.1.5, 51.1, 51.5 times 3, right? Which is 154.
154.5.
154.5. What's that going to give us? 6,000
for 1 sir.
divided by 154.5. It's going to be what? 40.77, right? Or 40.1. Yeah. Or 41, right? So we see that when we are having our panels, right. When we have our panels in series, like the whole 9 panels in series, we are going to require a less amperage, right? Then when we are connecting them 3 in series, we are going to require a higher, amperage of panels, right? Ken, I don't think you are still part of this lecture, because I keep seeing requests that are not being accepted.
Yeah, this person joined, like I admitted, I think he rejoined again or something.
Yeah, because network concept, or probably you're in a Zoom meeting, somebody calls you, it disrupts your network, Zoom will log you out, then you need to log in back again. So
I think that was what happened, because I admitted him, so he rejoined again, and I just admitted him now.
All right, so we understand it. So when we now decide to put 9 panels in parallel, you should be able to now look at how much current, okay, let's just conveniently just put it. So 6,300, right?
Yes, sir.
Divided by 51.5. So we're going to see that we need about 122 amps. Okay, so we've seen the effect of you design system and have try as much as possible to have a higher voltage. Okay, as far as DC is concerned, high voltage is always better. It's more reliable. Okay, so and also I want us to remove that mindset that some of us are already practicing. People will always tell you that hybrid inverters are not very reliable, or hybrid inverters are the transformer based or non-hybrids are stronger, and it's a lie. It's the same components that are inside. Okay, so let's let's proceed. So we've already
Hello, sir.
yes, I'm with you.
Hello, sir.
I'm with you.
Yes, I came across one of my boss some while ago now. So he now said I wanted to purchase. I mean, I wanted to buy a hybrid inverter for my client. Then he now said, why shouldn't I go for the transformer base? Now said he said his own reason was that whenever there is I mean, is it art fault or this
Thunder strike.
thunder strike sensor that non-hybrid inverter usually get damaged by the charge controller. So that the hybrid inverter is inbuilt with the charge controller. So he now said it's usually easy. I mean, difficult to repair the panel for the hybrid than the transformer based one. So I want to confirm how true is this. So he said he has encountered some of it before that. Dealing with the panel for hybrid inverter is usually difficult compared
Right.
to
It's right.
transformer based.
It's right. But that doesn't really
Okay.
mean that. That doesn't really mean that you it's because you didn't set your panels, right? That is why your inverter gets burnt or gets shorted. Now,
Okay.
from my experience too, fixing a hybrid inverter is always very difficult. But the same way your non-hybrid gets spoiled whenever there is thunder strike, the same way your non-hybrid also gets spoiled. So two of them still get spoiled. Just that the other one is difficult to fix. But it's difficult to fix when you didn't take it to their service center. Because that is one thing that some people do. You bought a Felicity inverter, for instance, right? You want to repair it, but then there is this your guy that is repairing inverter in Oshodi. Want to take it to him, because if you take it to the service center, it might take maybe 1 week. Then the person in Oshodi will go and do if you be the driver, so okay, this MOSFET don't burn. Let me change this one. Guesswork. They will just guess. Then they will join one wire. It start working. Then they will tell you they are fix it. But if you take it to the inverter service center, they already have it in their program. This is what is wrong with it. They already know what to change, and they will change it with the one similar to it. Because this these MOSFETs and resistors have color coding and numbers.
Yes, sir.
Sorry. So you might have something that is maybe 1058, and then somebody go and put 1059, and it's working. It still doesn't, which means the inverter has been altered. But the fact that it's working doesn't mean it's right. So whenever your inverter have issue, or whenever you want to buy an inverter, because that's how I went to go and buy one stabilizer. What's the name of that stabilizer? The name is very close. I didn't know that the stabilizer doesn't have service center. Don't buy any product that doesn't have service center. You see all these generic products you see in the market every day. All these Chinese people. If any Chinese person that approaches me for any collaboration, first thing I'm going to ask you is, do you have service center in Nigeria? I've battled. In fact, one man has stopped calling me for work because he wants to buy all these Igbo brothers that used to go to China. So once they want to flex their muscle, they'll go and buy systems directly from China. Prosper, mute your mic.
Now, I wanted to say something.
Okay.
Yes, I've had issue like this with most inverter. Even up to today, I couldn't fix the inverter that was since 2023 or 2022.
I have not. I don't
I
think
took this inverter to
does most
Yaba.
have service center.
I'm not sure anyway, but it was even my boss that bought the inverter then. So he was sending me to Abulegba to go and fix it. He was sending me to Yaba. Like, it was a whole lot of issue. And the client was mine then. I was still with my boss then. So at the end, we couldn't fix the inverter. And the client was looking for me. Like, it was a whole lot of
Going to
issue
cause
then.
issue.
At
It's
the
going
end,
to cause issue. In fact, I've been
yeah.
there. One guy bought one system from China. In fact, the system does not even have any online presence. So you have not, you can't even see other people that have installed it for you to add. Do you know what they kept doing? They would, send the board, and then they'll ask me to go and change it. I'll do video call with them. I will change board. I told them I don't repair inverter. I'm an installer. I was repairing inverter. I was repairing lithium battery. One day I told myself, what if this thing just somewhere, and what I know is that if inverter have issue, I take it to service center. What is inside the inverter, I don't know. My own is to design and install. I don't repair. So speaking of,
That time, I've been very scared of that most product. That 2022.
I don't even like
Been very
most
scared of them.
because of their terminals. Where you put your AC in and AC out. Once you try to tight it very well, to just pop. Anyway, let's not castigate any product. What you might not want to be
Moss,
using,
what do you say?
somebody
Moss,
else
is
use.
it MOSS?
Don't worry about products, please. I didn't want to start mentioning products in this our lecture. We are going to be
Okay, sir.
having special sessions for that later. And speaking
No
of
problem.
repairs, our next class we are going to be having one of the best repair persons on this our lectures. So he will tell you all you need to know about inverter maintenance. So that's the next class. So anything maintenance, things you can troubleshoot on site, things that if your inverter is doing, this is what it means, and how you can prevent this from doing like that. So hopefully, I don't know if it will be available because it's a very difficult person to hold on to. So I'll try to convince him for our next class, because our next class is Wednesday, right? Which is going to be our night. So I'll see how I
Nice
can
man.
convince him to be available. Okay. So let's proceed. But we've gotten how to calculate our solar panel sizing. So it's not always, because I think the breakers that are available in the market is always 63 amps. Most times once you want to do your solar, buy DC cable, DC breaker, you hear 63 amps DC breaker, 63 amps DC breaker in arena. Prosper, am I right? It's always
Yeah,
63 amps.
the maximum I've seen so far is the 125.
Yes, there is 125 amps, but there is 250 amps DC breakers, 300 amps, 400 amps. If you go to solar shop,
But those ones are bigger. But those ones are bigger in size now. It cannot enter that breaker box stuff.
no, they are MCCBs.
Okay.
Yeah, but that's still preview. So let's proceed. So now we are looking at design calculation for battery fuse and breaker. Okay, so breaker size. So when we look at this breaker now, we are talking about what? Breaker size is going to be, the breaker is going to be between your inverter and the battery. Okay, so I know most people don't use battery breakers, stuff like that, but you really it's very, very important. Okay, so always try to add it to your quotation. So there is this quotation, or there is a way we do quotation where some things that are not necessarily compulsory, you put them in a yellow, in your design, in your quotation, you put them in a yellow space on your quotation, so that the client will know that, okay, this is not like compulsory without the system. But I'm not saying you shouldn't add it to a quotation. But in a situation where the client cannot afford a battery breaker and you have your, DC breaker, you have your AC in and out, you have your bypass switch, and maybe it's a lithium battery. Lithium batteries have their own switches and breakers. Okay, so that's that. So let's look at breaker size. That's breaker size between the inverter and the battery. Okay, are we good?
Yes,
sir. Yes, sir.
Okay, so we are looking at inverter size, inverter power, times safety factor, then all over what? Battery bank voltage. Okay, so
Yes, sir.
let's assume now we are working with a 5 kilowatts inverter. 5 kilowatt. Okay,
5 kVA. 5 kVA, you mean?
5 kilowatt, not 5 kVA.
That's very
Okay.
powerful.
Okay, so 5 kVA is 5,000 watts, right? Times safety or factor, which is 1.25, all over battery bank voltage. Let's assume this system is a 48 volt system. Okay, so what are we going to have? 5,000 times 1.6, 1.25 is what?
6,250.
6,250.
6,250. All over 48 volts.
130. 0.333.
130.0. There is no point. There is 2. It's not up to 5.
Okay. So when you want to, that battery breakers are usually MCC based. Okay. I have. I don't have a battery. I don't have. Okay. I thought I have a, like a visual to show you what MCC based looks like, but I don't have a visual in this. But Mr. Abbott is taking us on system grounding, so I think he might probably touch it and get the visuals from there on his slide. Okay. So if you are working on a 5, so when you are working with 5 kVA inverter, so the battery, the breaker size you are going to use between your battery, especially if it's a 48 volt system, because most 5 kVAs are 48 volts, is 130 amps. Okay. So from 130, that 130 amps, but what is usually available is either 150 amps or 125 amps, then 250 amps, and and bigger ones like that. Okay, so you should know that from 150 amps we are good to go. Okay, so let's take one example. Say an inverter has.
Sir, please, I have an question, please.
Okay.
This 48 volt system, I guess, is let's say one battery bank. Let's assume you have let's say 2 battery bank of 48 volt system or 3 battery banks of 48 volt system. Will it still be the same breaker?
Yes, it still be the same breaker because you are working with the battery bank voltage. So if it's the same, if you have 48 volt system, like 3 banks, it's still the same current the inverter can pull at a time.
Okay.
Yes, why you are having the 3 banks is because you want the inverter to pull this current over a longer period of time.
Yes.
It's not pulling them instantaneously. So it's the same. You are working with the voltage of the bank, not the amperage or how many banks there is.
Okay. And the last one, please.
Okay.
So solar panel, like the size of or the power of solar panel, doesn't it contribute to maybe this battery breaker size of a thing? Because I believe once the panel is charging the battery, both the panel is generating is entering into the battery. Then inverter is also uh, drawing power from the battery. So I was thinking that since because the amperage will increase, the one coming from panel, then the one.
Let me illustrate it for you like this. If you have a 5 kVA, let's say it's hybrid. That's what you are saying, right? If it's hybrid, then power will be going in and coming out, right?
Yes.
Okay, now I want to let you know that the priority or your inverter works this way. While your inverter, the solar panel is coming in, right? Now, when the solar panel comes in, the inverter does two things. Is it that send that DC into the battery or convert that DC to load? So your inverter is doing one thing at a time while the sun is on, or you can say that, okay, there is NEPA, and then there is sun during the day, right? So the DC is coming in, the AC is coming in, right?
Yeah.
But charging the battery requires what? DC. So that AC that is still coming in from NEPA will be converted to DC. And 5 kVA inverter cannot cannot consume or send more current than it is designed to. So this calculation we are doing is based on that is 5 kVA. This is how much current it can be able to draw at a time. And also to mention that the charging algorithm of inverters are designed to deliver specific current based on the, what we call BMS, right? The BMS in the inverter and the battery is, synchronized together. That is why it's always very, very important that your battery, especially lithium batteries, and your inverter is communicating.
Yeah, it's communicating.
So that to be able to deliver the current that is needed to charge that inverter at that particular stage. Okay. Yeah. So as far as it's a 5 kilowatts, it cannot pull more than 130 amps, it cannot put more than 130 amps on a 48 volt bank. In fact, if the voltage is higher, the current will even reduce.
Okay.
Because power is equal to voltage times current.
Yeah.
The more voltage you have, the lesser current you have, but you still have the same amount of power. I hope this is clear for everybody.
Okay.
Yes, sir.
Thank you.
Okay. So I think
Sir?
this example, we should not
Sir,
go.
I have a question, sir.
Okay.
Regards you were saying there is sun and there is NEPA light. Is it that as at that time there is NEPA light, the inverter will charge the battery? So sorry, my son is disturbing. Is it that the NEPA light is also charging the battery?
Yeah. So hybrid inverters work this way. That's what we call priority settings. Okay. So you can decide to set your hybrid inverter that even if there is sun, two of them with NEPA, that's your panels and NEPA should charge the battery simultaneously. Yes. But NEPA charging the battery simultaneously with the PV does not still mean that the inverter will have to pull more current more than the battery requires or more than the inverter can pull. You get me?
Yes, sir. Well understood.
Yes, sir.
Is it clear? So even if two of them are charging simultaneously, it's still one current that is going in. AC current cannot enter the battery because the battery is DC. So it's always DC current that is going to enter. So even if NEPA is there, DC conversion from the panel, and then the AC is going to be converted to DC to send to the battery. So it's still one current that is being sent to the battery. So a well calculated amount based on the battery need. Are we good? Are we clear?
Yes, sir.
Yes, sir.
Yes. Yes, sir. Yes, sir. Okay.
Okay, so we use the 5 kVA example already, and that is the example we have on this place here. So let's do this example, this classwork together. So I don't want us to. The last time we did a Google form with questions, most of us didn't answer it. So I wasn't really happy with the turnout. Okay, so let's do this classwork. Chinemerem, right? Omalaha.
Yes, sir.
Your raising up your hand. What is
Sorry.
it?
I wanted to ask you, so you just say something. I see that the inverter converts AC current to DC and sent to the battery, right?
Yes.
Okay, so I want to ask because I know why in school then they told us that inverter converts DC to AC, then rectifier converts AC to DC. Does that mean that the solar inverter also has a rectifier inside which converts the AC to DC to send to the battery?
When I say inverter is made with what? Of course, there are rectifiers inside your inverter.
Okay.
Yeah. So when you now want to call it rectifiers, is maybe when there's another component, like maybe your motor or your bike, that you require current to charge the battery using your rectifier. But inverter is built with rectifier. It's inside. Just like your MOSFET, the drive, and every other thing.
Okay, thank you.
Yeah. So let's do this classwork together. Someone of us, is there anybody that could take us on this? To be able to know the breaker size we need for, say, a hybrid inverter has a power
Yes, sir.
of 10 kVA. Connected, it is connected to a 96-volt battery system. What is the approach breaker size?
0.1, please.
Yes, sir. First of all, we must know our
No,
safety
Abdulaziz,
factors.
not to you again, not to you. Somebody else. I want somebody that haven't said something before.
Yes,
Or
sir.
should I pick somebody?
Yes, sir.
Yes, sir. Pick somebody, sir.
No. This other guy.
Hello, sir.
Yeah, you've been participating. I've been hearing your voice. I need somebody else. I don't want to point. I know we all agree that we are together, right?
Yes, sir.
Yeah, so I need somebody else that I've not heard their voice.
There's no woman in this our class, sef. Only hefty men dey here.
It's women registered.
Okay,
But
let me
so
help
far,
out.
I haven't seen them.
This is very simple.
Hello. Okay, I will pick somebody if somebody don't want to say something. So let me go to the participant. I'm going to pick someone. So, David Ihe Dioha. Are you with us? David, are you with us? You see, David is not with us. Then
I'm with you, sir. Network is bad here.
network is bad, but at least the network will be able to allow you to help us do this classwork with us, right?
Yes, sir.
Okay, so proceed, please.
So the breaker size we need
Sir?
We need a breaker size
Yes,
that
this
will
class work.
prevent a higher amount of voltage from entering the battery.
Yes,
From
yes.
the
Yes, the breaker between the inverter and the battery, yes. So what do we say is the formula for calculating the breaker size?
I'm not sure about the formula because I've been busy.
Okay.
Like if you can just remind me of the formula, I will
Okay, so since you're not aware of the formula, I want to pick somebody else. So now
Yes,
you pay
which
attention.
formula are you using for this one?
Okay.
Which
So,
formula are you using for this?
Sikiru, we are looking for. Are you with us?
Just come back. I want to attend to something.
Okay, so we are talking about the breaker between your inverter and the battery. So how do you calculate the size? Okay, so Dawood Akinwumi, can you help us to do it? Dawood Akinwumi.
Okay, yeah, I'm with you.
Okay, so will you help us to do the breaker size for this classwork?
Okay, so let me just try.
Okay.
Okay, so according to the question, our 10 kVA,
Yeah.
so which is the power capacity, times 10 kVA times multiplied by 1.25.
Okay.
So divided by our battery, which is 96 volts.
Okay.
So I'm coming on to you. Press my calculator.
Okay.
Hey, sir.
Yes, come
I have a
now.
question, sir.
Yeah.
I was.
Okay,
So
10.25 equals
I was.
to our 10 times 1.25 equals to 12.25, then divided by 96 volts. So that's it gives us 0.13.
Okay. It gives us what?
0.13.
Not 10.2. Yeah, that's 10,000.
No, now it's 10,000 we are looking at. You are not using.
Oh, it's 10,000. Oh,
Yes.
You are using
sorry.
You are using K
Oh,
instead of
oh
V.
yeah.
Sir,
Covenant.
I was somehow distracted. This 10 kVA, you know that not all inverter that this 10 kVA is equals to 10 kilowatts,
Yes.
depending on the power factor they are using.
I'm waiting for him to finish.
Okay, our total answer is 130. 130.
130.
Yeah, that's 130. Yeah.
So 10 kVA, 10K, this 10 kVA is equivalent to
10,000.
Is this 10 kVA the same thing as 10 kilowatts?
Um.
No.
Yes.
10 kVA and 10.
No,
No, 10
I
kV
not the
and
same
10
thing.
kilowatts is not the same.
And I said in the formula that we are using kilowatts, right? Not kVA.
Yes.
We are using watt arm. So 10,000 kVA, 10 kVA is equal to how many kilowatts?
8 kilowatts.
Yeah?
That's 10,000 watts,
8
right?
kilowatts.
8 kVA is going to be 8,000 watts.
This 10 kVA
10
is equal
kVA.
to how many kilowatts?
8 kilowatts. 8 kilowatts.
8 kilowatts. Our breaker size calculation is going to be 8,000 times
Okay.
1.25, which is equal to
Okay.
10,000.
Okay. Okay.
Yeah. Then times, divide by what? Our bank
96.
value, which is 96, right?
Yes.
So we
Yes,
have
sir.
104. Okay? Is it clear?
Yes, clear.
David, that would have called me. Did you get it?
Yes, I can hear you. So how with from our 10 kVA, so how do we
Yeah.
arrive at
A bit
a
of it.
kilowatt? That's what I want to
I
get
just want you to
correctly.
get your answer
So
that.
we are going to times this your KVA
Yeah.
by 0.8, which is the power factor.
Okay.
Yeah.
Okay. By
So if you
0.8.
want to do your breaker size, you have to calculate it with the actual power.
Okay.
You know, they say that Mr. Abbott, right? Let me use the example that are peculiar to all of us. Or maybe
Okay.
not all of us. All of you that drinks beer. Me, I don't drink
Not
beer.
me too. I don't drink beer.
I
So
dey take beer.
uh, one of my
I,
guys said that he doesn't take beer, he takes life. So I want to tell you.
You're talking to me.
No, I wasn't really talking to you. I said I want to give an example to let them understand the difference between kVA and kilowatt. Okay?
Okay.
Yeah. So kVA is like Albert drinking Gouda, and then when he pours the Gouda from the bottle to the cup, you know that it's going to foam, right?
Yes.
So when the foam gets to the brim of the cup, he will stop pouring so that it doesn't pour down, right? But then you'll be seeing another clear version of the beer beneath, right? So the kilowatt is that the Gouda itself that we are seeing. Then the kVA is that foam. So you see that the kVA is always bigger because the cup are full, but the beer have not full the cup. So in normal terms, we call it apparent power versus real power, or empirical power versus real power. So the Gouda is under, but the cup has full. But that doesn't mean that it's a full cup. Understand? Is it clear? Chidemere, you're raising up your hand. What is it?
Please,
Yes, sir.
please, sir.
I want to ask a question.
One person at a time. Francis, wait. Let Chidemere ask.
Okay, thank you very much. So you are saying that most 10 kV inverters, the real power is 8,000 watts.
Exactly.
But I've come across an inverter that is 10 kV, and they say the real power to, from the inverter specification, the real power to is also 10,000. So I don't know, is that still possible?
Some inverters, their power factor is 1.
Is 1.
So when you look at inverters like the Outback I mentioned before, when you look at inverters like Vitron, Schneider, okay?
High power for inverters.
Understand? So all these, American spec, high quality inverters, their power factor is always 1. Okay, so those ones, if it's 10,000 watts, it's 10,000 watts.
Okay.
But these are our Felicity, SIN, and the so many brands that we have available in the market. Tinubu say,
But God's power.
Nandi.
God's power.
Felicity, their power factor is 0.8. I'm sure of that. Their power factor is 1. Most their power factor is 1. I think their power factor is also 1.
So what the essence is this, the power factor of each inverter is always dictated on the inverter. So no argument on that. But whenever you have a new need for you to convert your kVA to inverter to kilowatts, you know what to do. You times it by 0.8. Then when you need to convert from kilowatt to kVA, you divide by 0.8. Are we clear with that?
That's the question I'm about to ask. Thank you so much, sir.
Okay. So when you are doing the conversion,
Can you see that again? Can you see that again? How to convert kVA to kilowatts, please?
That's what I'm trying to say right now. From kVA to kilowatts, you times by 0.8. Okay? Then from kilowatt to kVA, you divide by 0.8.
Divide.
Yes, divide. Okay? Are we ready to proceed?
Yes, sir.
All right. Okay, so we've done this calculation. So we got 104, right? So there is no 104 amps in the market. So you are going to get around 125 amps. I made mention of that when we got that 130, right? So there is no 104. So you go for a higher one, which is 125.
125.
Okay?
Yes, sir.
Okay, I should also mention that
I have,
when you are going
sir.
for the next higher one, it should be within range. Okay, you don't go and where you are supposed to use 120 amps, you go and use 250 amps. The essence of the breaker will be depleted because it's not going to break. You will fry the system before the breaker even notice that, okay, I've been overpowered or the system is being overpowered. Okay, and the essence of not using a lower one is for it to what, not still triple, because when you have where you're supposed to use 125 amps, you use 95. So when the inverter tries to exercise its whole power, then the breaker will say, you are choking me, let me run, and it will trip off. Though some inverters, some breakers not the triple. So whenever you buy breaker, if you like, go and buy nonsense. In as much as you want to size your system with breaker and calculator, buy original products, because some breakers or many breakers you have in the market, all these things you see as Schneider breaker, ABB plus, is it ABB and T? Yeah, something like that. Mm-mm, 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 mm-mm. It's not the original one. So even after your calculation, it will still not. So
Which one is the original one? Oh?
those ones you have the name, but get the original one out of. You go to the market, second to original day, first to original day, third to original day, semi-original day. Okay? So
Which can tell us
Before
those ones?
original country.
there is this thing, this way you talk now. One of our facilitators when I was in uni is a Yoruba guy. So he said the first time when he went to Imo State to serve, that there is this Igbo man that is selling provisions, he's selling milk, liquid milk. So he asked the guy to give him peak milk. He give him peak milk, and he said it was 17. That time when things were good, though, I just learned recently when I went to go and buy milk that one is like 800 now. So you gave him that one 17 naira. The way the body of this thing is looking, he said, that he doesn't like this one. I say, do you want the original one? He said, yes, that I want the original one. He said the original one is 120. So no matter what you are looking for in this country, especially in this our solar industry, if you are looking for 600-watt panel, 400,000 a day. If you are looking for 600-watt panel with 50,000 a day, just the person will just tell you, give me small time, let me bring it for you. You will go to the back and do the magic and give it to you. In 2021, when I was still even new, that was when I was like, still, I'm just coming new into the field. And, I was formerly a blogger before I start practicing. So that's why I know a lot of theories before I started doing practical. And then I studied physics, of course. So it helped me to master all these things. So There is this client I have, he stays in Spain. He's a Yoruba man. So he connected me to his brother that is here in Lagos. We linked up. They took me to their place. I, sized the place and then recommended the system. He said, okay, he's going to do it instrumentally. So he was supposed to have 40 panels of 550. No, that time it was 450 watt that is like highest. So, what is this one? So, long story short, we started buying the panel. So then 450 watt panel was like around 94,000. So I was selling it for him at I think 105 or so. So he bought the first 15, we took it to Ibadan. He bought another 15, we took it to Ibadan. So the remaining 10 now, he said somebody is supplying him that 10 in that he got somebody that is supposed to supply him that panel. That why would I be selling panel 105 for him? Why somebody is willing to give him the panels at 64,000? I said 64,000. Yes. 450 watt panel. He said yes. I said, no problem. Because me, I'm buying it from the factory guy that is importing it directly, Mr. Charles. I'm buying it from him 94,000. In fact, I even told him that this panel I'm buying it from the person that is importing it for 94,000. That there is no way I'll be buying something of 64,000 and I'll be selling it for 105. The gain margin is too high. Conscience won't let me do this kind of thing. He said, no, that all this Igbo voice. I said, no problem. He bought the panels. I went there. First thing first, the panels that he bought was not 450 watt. They were 250 watt panel. Amongst the fact that it's 250 watt panel, I told him I'm not going to install them. It's against my, professional principles. And then one of the panel was not even working at all. It wasn't giving output, not even voltage, or not to talk of current. At the end of the day, that was how the contract ended. He paid me money to buy the mounting rails and I installed the 30 panels I bought. I told him the remaining 10. I'm not installing them. That's how the whole job went. Fast forward to after 2 years, the brother reached out to me. No, the father, because I connected with the father because the father was an electrician. He was not in Lagos then, so I connected with him. We chat, we talked. Then after like 2 years, the father called me. I was surprised to see his call. So he called me and said, my son, help us come and look at this system that all the batteries, they are swollen up because he bought this OPZ batteries, 2 volts, 1,500 amps. I think he had 24 pieces of it because it was a 8 volts, design. But I told him, I don't know how we used to do that thing, but I'm trying to imitate it. I told him I'm not coming. Like, you've called somebody else to, continue with what I said I'm not going to do because it's against, what you bought was rubbish. Then somebody else come and help you to, maneuver the rubbish. And then he's giving you issue. The battery is looking like it's about to explode. Say, I should come and then hug the battery to make it go back inside. You've damaged the system, is that you've damaged it. The guy wasted money. Then the brother called me again. I said, I have to help. I said, no. Said that the guy in question doesn't know how he's going to come. I said, well, that I don't have conscience to pity him and decide to come and go and do what I know I cannot do because the system is damaged. If the batteries are looking swollen, there is no way you are going to make them again to come back to normal. What you can do is to revamp the system, remove those batteries, and then look at what went wrong and then correct it with another batteries. And besides, I'm not going to come and do it, even if how much you are paying. So most times when clients want to convert you into doing what they think is right, believe me, if something goes wrong, the client will not explain it that you said it. The client will say, who did this job? It's Prosper that did it. You understand? So at every point, make sure you try to maintain your image. if things go south, the client will protect himself, and then he will start telling you how much is this thing. Some clients are very funny. That time people are discussing his bargaining seriously, but then if you decide to compromise something and reduce that money he's telling you to reduce, if something happens, he's going to tell you, if I can pay 5 million, why can't I pay 5.7 million? What is 5.7 million? If I have paid 5 million, what is now 700? But he was the one pressing you to, compromise something. So always make sure you maintain your ground. And some customers won't be happy if they try to convince you and you don't agree. Some of them that attended the talk would like for you to, be assisted for them because they are grounded
But
position.
nísìnyí kọ́lí tí mo yàgò síra wọn kápá
Hero,
bẹ́ẹ̀
please.
àyàpàdé. náà tí mo rẹ́ ìgbẹ̀dẹ̀ sọ. ṣé pé wà náà ṣe pẹ̀ bá mọ̀ ni irú yẹ èèyàn bá mi sí wa.
Demo, please. Mute your mic.
Mo ní ẹgbẹ́ bẹ́ẹ̀ yẹn bá dá mọ́ wà tẹ́yẹ̀ ń ṣe lókè yẹn ni irú ìgbé ọkọ̀ afẹ́lẹ́ yẹn.
Chicken room, mute your mic now.
Okay, so don't sorry about that. Let's proceed. Ken, I will get angry with you. I shouldn't be the one doing this. Somebody is shouting, you're seeing it. I'm not even sure if you are here.
Yeah, my phone was angry. I was trying to bring it up.
Leave it. Don't worry. Please, let's proceed. So what I'm trying to say is, in as much as you do your calculation, you got everything right. Also buy quality product. That's the whole moral of the whole story. Okay? So try to buy quality product to commensurate with what you've calculated, and so that you won't do the right thing and then it's the components that will fail you. So let's look at this one. Is going to be quickly because it's after 12 already. So we decided to make the class to be 2 hours because the last time people were complaining that the class was long. So let's just rush over these few ones so that okay, these slides were. I'm not going to send you this slide because the classwork, the answer is already there. So okay, so let's just rush through it. I think what is remaining is just the the backup time. And then, okay, so we've done this, right? So what is next is calculation for AC input and output breaker. Okay, this is for the AC side now. Okay, so let's just rush through it. Okay, so breaker size is equal to the same thing. Okay, output voltage. So it's the same thing. So the other one we are using battery bank voltage, right? Because it's between the battery and the inverter. So this one that is input voltage, so we are going to be using output voltage. I know that output voltage is always the same thing as input voltage, right? So, and what is our input and output voltage? 220 amps. I mean 220 volts.
20 volts, sir.
Right?
Yes, sir.
So it's the same thing. So if you have a 6 kVA, what do you do first? You convert it to the real power, right?
Yes, sir. Multiply by the
multiply by what? The safety of factor, which will still take you back to almost the same thing.
To 6,000, yes, sir.
Yeah. So what do you do now? Divide it by 220. So it's simple.
Yes, sir.
Okay?
27.27. So approximately 30 amps.
Yeah. So see, in AC on is very, very important and very, very crucial. Don't always use 63 amps for your AC input and AC output, because some customers will go and plug something. So instead of the inverter tripping off, the breaker tripping off, the inverter that is going to show you overload. So just for a quick one, whenever you have a 5 kVA inverter, just know that your AC input should not be more than 30 amps. and your AC output should not be more than 20 amps. Okay? Okay? So
yes, sir.
Sir, please can you say that again? Please can you say that again?
I said whenever you have a 5 kVA inverter, always make sure that your AC input does not exceed 30 amps. Okay?
Okay. Then the output.
And the output should not exceed 20 amps.
Okay.
Yes,
So what
sir.
of the pattern less than 5 kV or higher than 5 kV?
Some breaker size. So if you let's say that is going to be a 3 kilowatt inverter, right? Or 3 kVA.
Okay, sir.
Okay, so 3 kVA that's 3,000 watts, right?
Yes.
Okay. Divide by what? The output, right? Which is 220. So you see that it's literally like 13.6. Okay. Another best way you can do this is this. If your inverter is 3.5 kVA, you can say this 3.5 kVA divide it by 20 amps. Sorry.
Like 220.
You times it by this 20 amps you times it by the voltage 20, which is like 4,400 for a 5 kVA. Okay, so you expect that the client is not going to put anything above 5 kVA. But see, the best option is for you to use this formula. Divide it with the voltage of the inverter so that at any point the person don't have to pull anything above what he's supposed to pull from the inverter. So the inverter doesn't have to like make noise, complain of any high voltage or overload. Okay. So
okay, sir. Thank
have
you.
your 3 kilowatt, use the formula. Okay, get the appropriate breaker size and quality breaker. Okay, so that even if there is a excess power going into the inverter, your breaker will be able to trip and all that. So that being the case, I think that is simple. So there is this classwork. So I'm going to send this slide to us, right? Then we'll copy this classwork from the slide. So when I'm sending the slide, I'm going to remove this solution. Okay? So let's proceed to solar panel charge time. Okay? Are we together? So I want us to rush over this thing because these things are not it's not very hard. Okay? So if you're looking at solar panel charge time, okay? So we said that solar panel charge time is equal to what? Battery bank. Okay? Battery bank capacity. Okay? All over what? The solar panel power capacity. That's the solar panel power. What this means is this. Your battery bank capacity, which means like, let's say 17 kilowatt hour, 15 kilowatt hour. All right? Then if you now have your, solar panels, the total power, okay? So now let's say, for example, now we have a 17 kilowatt, okay? And then you have 17 kilowatt. In real life, you have to like calculate the total power first. So what you are going to do is say, okay, 17 kilowatt, how much? If I'm using, let's say I want to buy 550 watt panel. 550 watt panel. I want to buy 12 pieces of it to use it to charge the 17 kilowatt. So the question now is, if you buy these 12 pieces of 550 watt, how long will it take before it charges this 17 kilowatt battery fully? And let's not forget that the amount of sunlight we have in a day is restricted, right?
Yeah.
Calculation, right?
Hello, sir.
Sir, I'm with you.
Yeah, I mean, the network logged me out a few minutes ago, a few seconds ago, a few minutes ago, sir.
Okay.
But coming here now, I just see like two, or I'm lagging behind about 2 slides. Is it this one?
Okay, so if you are lagging behind by 2 slides, we are going to have a class at night because our facilitator today couldn't make it, so he said he's going to be available at night.
Okay.
I'm going to, let him take us at night. Then the things we missed. Then maybe he will be able to touch it. So if you're available, you can still join. Are we cool?
Okay, all right, sir.
All right. Okay, so let's proceed. If you have this 17, so now we are using 550-watt panel, 12 pieces of it, right? So what is now the total capacity of our panel? It's going to be 550 times 12, right? Are we good? Hello? Okay, so this is 17 kilowatt hour all over 6.6 kilowatt, right? So, in normal calculation now, okay, let me not say in normal calculation, but if you put 17 kilowatt hour over 6.6 kilowatt hour, I mean 6.6 kilowatt, right? So you see that this kilowatt is going to cancel the kilowatt up. So you have 17 divided by what? 6.6, which is going to be 2.57 hour. So if you are using
Sir,
pieces
sir,
of
are you working on this current slide, sir?
Yes, this current slide. Though I'm just giving you an example. I'm not using the example
The numbers, the
yet.
figures.
I'm just
Okay.
explaining first. I'm just explaining first.
Because I was just hearing 17. So
Okay. Okay. So so let's use the example that are on the slide. Okay. Are we together? I want us to proceed. Our time has already passed, so that.
All right, no problem, sir. We are with you.
We are together, sir.
Yeah, not like our time don't pass. Like, I mean, the time at which we are supposed to, round up things. Okay.
Oh, June is Shusha.
Sorry. Okay, so example, a solar power system has a battery bank that consists of 4 pieces of 200 amp 12-volt batteries. So let's get it one after the other. So our battery bank is what? 4 pieces, of 12 volts, 200 amps. So 12 volt 200 amps is what? In kilowatts? That's 12 volt times 200, right?
Yes, sir.
Yes.
2,400. Then times 4, Abi, because we have 4 pieces of it, right? That is what? 9.6 kilowatt hour, right?
Yes, 9.6.
Now, it's connected in series to a 5 kVA 48 volt inverter, right?
Yes, sir.
Okay. Now, and 8 pieces of 400 watts solar panel is connected in series parallel. So determine the following: system voltage 1. So system voltage here is what? Somebody?
System voltage is 48 volts.
Is 48 volts. Very good. So battery bank capacity is what?
9.6 kilowatts.
Very good. Then solar panel capacity is what?
That's
3,200.
400 times 8. Let me check.
400,
3,002.
3.2 kilowatts, right?
Yes.
Okay, so the battery charge time.
3 hours.
Okay, so the battery charge time now is going to be what?
3 hours.
How do you get 3 hours? 9.6 kilowatt hour. We all over what? 3.2 kilowatt, right?
Yes.
So
Yes.
that's going to give us what?
3 kilowatts and 3 hours.
It's going to give us 3 hours, right?
Yes.
So if you are using 8 pieces of 400 watts, in 3 hours our batteries will full, right?
If only the panel is generating up to 3.6 watt too.
Exactly. So for this is theory, this thing, right? So what happened when because panels are not 100% efficient. So in real life, when you are calculating this, you have to add the efficiency of the panel, which I told us we are, or to be on the safer side, if you are buying premium panel, always use 0.73 as the efficiency. But if you are buying other generic panels or used panels in the market, please use from 0.5 to 0.45.
Okay.
Yes. If it's premium panel, use from 0.3, 0.73. But if it's all these random panels in the market, use from 0.6 down or 0.5 down. In fact, currently I'm facing an issue where a client of mine in the island, he has 8 pieces of 350 watt panel, and no matter the intensity of the sun, the panel recently started producing 700 watts at peak. So I'm still looking. In fact, what I'm waiting for now is the solar panel meter that I ordered to arrive, so that I can go and test the panel individually and know which one now have issue, because at the time I installed it, it wasn't like that. In fact, that particular site has faced a lot of issues. It's that same site that somebody has gone to remove that part, remove my client's panel and connect it to the next person's panel, thinking that the panel belongs to the client, because all these duplex terrace, the roof is not demarcated. You understand? It's a complete
Yeah.
roof. Understand?
I have solar panel meter now. So I bought from me, sir.
You
Instead
have
of
solar.
ordering online.
You can as well send me one now. Let me use it, because I don't normally have this kind of issue. So I'm just buying it for this site.
I need for selling.
Okay, you have for sale. Okay, can we quickly do this one? This last one. Can we do it here?
Yes, sir. Which one?
A battery bank of 200 amps, 12 volts, connected in series parallel
Okay, sir.
48 volt hybrid inverter and 24 pieces of 400 watts. So let's assume we have already established that one single 12 volt 200 amps is 2,400 watt hour. So what we are going to do in this case is just 2,400 watt hour times 12, right? Which is going to give us what? It's going to give us
28,800
watts, right? And our panel capacity is going to be 400 watts times 24, right? 400 by 24 is going to give us 9.6, right?
Can you come again, sir?
Our solar panel capacity now is 24 pieces of 400 watts. So 400 watts times 24 is 9.6 kilowatts, right?
Yes.
Okay, sir.
Yes, sir. So in this case now, what is going to be our system voltage?
48.
48, because the inverter is 10 kVA, 48 volts, right? Then our battery
Yes.
bank capacity, we have gotten it, which is 28.8, right?
Yeah.
I hope everybody is getting this together as we are doing it.
Yes, sir.
Yes, sir.
28.
Yes, sir.
Okay, good. So our solar panel capacity, we have gotten 9.6.
9.
So the charge time is going to be now 28.8 kilowatt hour all over what? 9.6 kilowatt.
That's
You got to
2.7
3.
hours.
What?
2.7 hours.
How many hours?
No,
That's
3 hours.
2.7, approximately 3 hours.
It's 3 hours now.
Yes, sir.
It's
This
3
is
hours.
not clear anymore. This is not clear. You said the battery bank capacity in kilowatt hour is what now?
In kilowatt hour is 28.8.
28.8. Okay.
Yeah, divided by 9.6 is going to give us 3 hours. So another thing we are now looking at this is this. If you calculate your charge time, and is not commensurate with within the peak sun hour. In Lagos you say we'll use 4.5 or 4 or 4 points. In the north we'll use 6 hours or 5.5. In Abuja we'll use 5 or 5.5, right? So if you calculate your charge time and it doesn't fall within this PSH, you know that your battery might probably not get filled up at the end of the day before the day runs out, or maybe you are going to use NEPA to commensurate to it, which is not efficient. You don't do your designs to include NEPA to it, except in a situation where the client tells you that, okay, this is what I can afford for now. Let's use NEPA to augment it depending on the time when I can go, full solar. Okay, so I think of so okay. Next thing we are going to do is backup time calculation. Okay, so which is very simple. I think we looked at what backup time is and DODs and all that, right? Right. So let's quickly look at the last one, which is the backup time calculation. Okay. Are we together? So let's
Yes,
proceed.
sir.
Yes, sir.
So let's proceed. So backup time is or the days, you can either call it backup time or how long your battery is going to last, right? Is equal to battery bank capacity, right? In kilowatt hour all over what? All over the load you are
Total
consuming.
load.
Yeah. So let's take this example. A 50 kilowatt solar system was designed to provide uninterrupted power supply, to a facility with a total load of 40 kilowatts. Okay?
Yes, sir.
So the load is what? 40 kilowatt.
40,000 watt.
Okay. Now, they say 40 pieces of 10 kilowatt hour lithium batteries were installed at the facility. Okay?
Yes, sir.
Now, which means our battery bank capacity is what? 40
by
times
10.
10. Which is what? 40 times 10 is 400.
400 kilowatt hour.
400 kilowatt hour. And then they said, and 300 piece of 400 watt solar
400
panel
watt.
to charge the battery bank. So solar
yeah.
panel capacity is 300 times 400.
400.
300 times 400.
400.
It was 120 kilowatt power. Now, they say assume a DOD of 80%.
80%.
Right? So, which means if we come to this, our battery bank capacity, we are going to times it by what? 0.8.
0.8.
So, we have 400 times 0.8, which is what? 320
kilowatt.
Are we good?
Yes, sir.
So, when I say determine the battery backup time when the inverter is loaded at full capacity. Okay?
That's 8 hours, sir. 8
So
hours.
what we are going to do now is going to be 320 kilowatt hour all over
Divided
what?
by 40.
40
40,
kilowatt.
That's 8
40,000.
hours. 8 hours.
So 320 divided by 40, right? Is
Yes,
8
sir. It's
hours.
0.8. Yes, sir.
So when you load this battery fully, you are going to have 8 hours, right?
Yes, sir.
Now,
What's sick?
total solar power generation per day,
Yes, now.
right? Assume a
Yes.
PSH of what? 5. So PSH, SPH, they are all the same thing. Solar peak hour or sun hour, anyone. Okay. So that's going to be what?
600 kVA per
It's going
day.
to be 120 times 5, right?
That would do a 600.
120 times 5. 600 kilowatts, right?
Per day. Yes, sir.
Kilowatt power. Okay. Now, the backup time. We have calculated it, Abby.
Yes, sir. That's 40 kilowatt load.
Okay, that's supposed to be the battery charge time. Sorry. Okay. I don't know why I have this because I have it at the beginning. Okay. So what is going to be our backup time? Is battery bank capacity divided by what? The load, the solar power capacity, right? Which
Yes,
means
sir.
our battery bank capacity is 400. Let's not forget that it's not 320, right? 400 kilowatt hour all over what? 120 kilowatt, right?
Yes, sir.
So what's that going to give us? 400 divided by 120 is going to give us 3.33 hours. So a PSH of 5, which means we have enough time to, charge our batteries, right?
Yes, sir.
But there is one thing we need to understand here. Just like I said, for every design you want to do, always make sure that you know the usage of the power you are trying to design for. What I mean by this is like this. In this my house, if I'm not at home, the only thing that is on in this house is my fridge, which is like 150, 170 watts, right? So if I'm designing my solar, I'm going to design it that, okay, this is the load that is going to run for 24 hours. You put it down. Then if I come home, I will on the fan in the parlor. Of course, my sound system, that one is not, no compromise. Once I'm around, the sound system is on. Then the fan in my bedroom. What else? My 2 laptops. Nothing again. Maybe I want to use, the electric kettle or something like that. So when I put this, let's say I'm a 9 to 5 person, which means I have a routine. So if I leave around 8 a.m., I'm coming back around 4, right? So when you want to make a design, you follow the pattern at which the person is using this light and know the time when the battery will start working. For instance, if you are designing a system for such a person like me now, you see that when I will start using the battery, when I will start using the power, like much of the power, the solar is already gone. From 4 o'clock, solar is literally producing less to nothing, right? Reasonably small. So which means that from this 4, I might probably start, depending on the battery. So the power that, okay, from this time, this is how much power he's going to be pulling on this battery till this time. So that when you size your battery correctly, okay, so it will be able to take him so time. Okay. Now, another thing you need to also consider is that while you are considering your charge time within this your PSH, you should also look at the fact that there's some certain load that is going to be on as throughout this period. You do get it?
Yes, sir.
You understand? Good. So when you are designing to full the battery, also designed for the one that is going to be in use while the battery is being charged. Okay? So when you, that's why I said that when you calculate the total power in the house now, that the person consumes in 24 hours, besides the battery, that your goal is to be able to generate the total power that the client is consuming in a day, within this 5 hours of PSH or 4.5 hours. So in that case, you don't have any flaws in your design. Okay? So this is another classwork, but I'm going to copy it to be part of the assignment. So I will join that classwork to this assignment. Okay? So this assignment, I will post it this night, hopefully. Then I expect that by Wednesday, we are going to, look at the assignment together. But then I expect you to submit it before Wednesday so I can review it. Okay? Are we good? So it's question and answer session. So sorry, the time, the class took more time than usual. It's supposed to be a 2 hours class. So Samuel, you raised up your hand. Samuel, I think you're just coming.
Yes, you log out. You can say,
due to the same network issues some of us have been having, I've been going in and out, and so many things I was
I've seen that.
didn't want to interrupt the flow, which is why I waited for the end. So is there a way that for us that has missed so much during this process, honestly, I just kept taking screenshots so that I can go over through some things later. But most of the explanation, I missed it. Is there a way we can catch up? Because
yes, I'm going to send the recording.
Just kept...
I will send the recording of the class to you. Okay, so you can go through the recording. Then if there's something you need to ask, the big phone number, I'm always in possession of it. So you can always, send a message to there. Okay. So send a message there, I'll get it and answer you immediately. I'm with the phone. Okay.
Thank you, sir.
All right. So do you have any other question, or in absence of that, should we call it a day?
Sir, no, sir.
Yes.
I want to ask the assignment, sir. Are we submitting through the Google Forms, or you have to write it down? Like,
No.
snap it to you?
I'm going to send it in a either a slideshow like this or in Word document, so that you can have your answer and have your answer in.
Sir, so sorry,
Okay,
I
sir.
just remember something now. Regards what I asked you the last time, with regards the chat control that is showing blank and coming back. You've not really given me a solution on it.
We are looking at it together. I was asking you the situation of the charge controller as at the time when it's showing the ink. Is it that there is NEPA there, or is the inverter overloaded? Because most times it has to do with your charge controller is showing ink on the surface. I've only experienced it once somewhere, and it is because there was an issue with the NEPA. The inverter was having issues, so sending power to the battery.
Mostly, I'm not sure I'm using too much load. Like I've told you the last time, I only have 5
When
bulbs.
you have this, what do you call it? Ink on your charge controller. Does
Charge
it?
control, yeah.
Yeah. Is there NEPA then?
Sometimes there is NEPA. Sometimes, like presently now, there is NEPA. Charge control is normal. It's working perfect. The screen is showing, and there is NEPA. So sometimes, even if there is no NEPA,
When that ink comes in, check the
yes,
time
sir.
of the day. It could be that maybe when when your controller is pulling more energy from the sun, it could be that that's when it disrupts with the energy or something. So you should know
Okay.
it's an issue with your. So try to monitor it when it's happening, so we can relate it. That's how we do troubleshooting. So you know
All
that
right.
it's not coming from inverter. It's coming from okay when the sun is like this, when the sun is like that. So
All right, sir. Thank you, sir.
okay. So do you have any other question? Somebody?
Yes, I have a question.
Can we turn on our cameras? I think this is the end of the class, so let's turn on our cameras so we can have a snapshot, please.
Please, I think we'll need to inform them, those in the group, because I can see the number of people right now has reduced, which means some people that joined us before has left already. And by the time we start trying to give the certificate, and we are like, some names are not like, because some people did not join completely, they might start saying they joined every single meeting, but then we only take the images at the end of the meeting. So that's just another issue, so that it doesn't look like, okay, I joined every meeting and my name is not included in the certificate. So I can see that some people that were here earlier, they left. So we'll just go with what we have now. Please give me a moment. I'll turn on my camera also, and we'll take the images.
So what are we? So the ones that their camera is still blank, are we? Is it that they are not with us? Samsudin and Abrazak, you are with us in the class. So why is your camera not on? Hello. Prosper. Chinecherem. Abi Chinemerem, sorry. Are you still with us?
Yes, I'm with you. I'm with you.
Okay, we want to take a snapshot. So I expect us to turn on our camera.
I'm actually waiting. I just have to put on what I'm doing.
So can I start taking the images?
Yeah, you can take a snapshot now.
Okay.
So we always want to take a snapshot so that we will know those present, and we know those that will proceed to the leadership training and subsequently the current exam. I think we should be fine now, right? We've taken the.
But sir, when they start taking a snapshot?
We've always tried to take snapshots each class.
Even during the night too?
Yes.
This is my first time of taking a snapshot too.
Yeah, we took it. We took in the last this thing. I think the first or second class, we did not take a snapshot.
Yeah,
so So it's just
what we've been doing is, we'll try to take snapshots of just the participant name, but we need to have it behind it. So we don't just want to be taking, just names. Okay. So Kenny, are you done?
Of course, everyone can leave the meeting. I have everyone's this thing, and please, I hope you are all using the names you used to register. It's very important.
So be able to.
Yeah. All right.
Together. Okay.
So there's no problem then.
So that being the case, if there is something you didn't understand or you didn't get properly, as we are on this class, I expect that the next class you'll be able to grab one or two things if you show up. So our facilitator, Mr. Larewaju Samson, will take us at night because he wasn't available to,
Hello,
take
sir.
us this morning.
But is that one compulsory? The night one?
No. If you've taken this one, you are okay. Just that, if you want to, if there's something you missed or you want to just go over it again,
Okay.
the way I
Okay.
explain things might not be
Hello,
the
sir.
way he explains, so you might,
I have
get
something to
it
say.
better.
Hello, sir. Hello, sir.
Yes?
About the registration forms, sir. You said the link have been expired before I could join then, and you told me I should not worry, something like that, sir. So, and Mr. Kenny is still talking about the registration now.
Yes, you need to send the information to him. So
Yeah,
find it
for the registration, we are not
on
taking
the
any
chat. You
registration
need to
again.
add your
Except
information.
you just send your information to me. If you use the link, it's not going to work. The link was only there before the program started. So immediately the program started, the link expired. Do you understand? So
Okay.
if you have not registered, I need to have your details. If I don't have your details, there is no how I can we can collect your name for the certificate that will be handed after the training.
Okay. I will send the details to you on WhatsApp, right? Oh yeah.
All right. Yes, please.
Okay.
All right. So thank you all.
What's
I want to ask again for the certificates and other things. What was the passing attendance?
70% attendance.
Or like you read 70%. So which means before it was even 100%. So you can see that the management has been lenient to give the grace of 70%, just for maybe for the issue of those that maybe they are not able to join due to network, or probably maybe something turned up and they needed to quickly attend to. So at least with 70% attendance, you should be able to at least have something.
Because
okay, sorry,
why
please,
I'm asking, because this is my first time of taking a snapshot.
Yeah, but I
And
always.
So let me see who is the person that spoke. Okay,
So the
Covenant.
snapshot that we took in.
Yes.
If the snapshot we have been taking of just the names, if your name appeared there, you are good to go.
Okay.
Yeah. So, and I also need to mention that, this training is just like the one we are giving you. We are going to still take our own exam, and then you take current exam. So we are working with, to have an MOU with current so that we can have you registered, and then in your various cities you can go and we'll get a center for you, and you go and take a current exam. That will be after your leadership training. So after this class,
Thank you,
you
sir.
take big turn exam, then you proceed to the leadership training. After that, you're going to take your current exam.
So I want to say something, sir.
In your leadership training, we'll be looking at how you can set up your solar businesses and how you go about it, from getting your first client to, practicing what you've done on site. And then we are going to have you, do internship with, some of the leading solar companies that have agreed to partner with us. Just like you heard from Mr. Larewaju when he was giving letter that if you have people that are in Lagos and want to, do internship at Massive Votes, that you're welcome. So you tag
Question,
along
sir.
with them for a few months, and then, solidify what you have learned. So then you are good to go. So we'll be taking up, helping you to do your business name registration, registering your company, and creating your social media accounts so that you can proceed with your business as a
I have
solar
a question, sir.
service company. Okay, Galila.
Yes, sir. I want to say something, sir.
Yes,
Before we
I have
go.
a question.
Hello, sir.
Sir, I wanted to ask how about physical
Let
training.
Lawal ask first. Sorry.
Yo, I just wanted to ask about the physical training, sir.
So the physical training, Lawa, where are you?
I'm in Kaduna State. I'm in the northern part of the country.
We are in Kaduna. Okay, so we
Yes.
are working something up in Kaduna, but I'm not. Our business manager is not here, so
Okay.
brought me up to speed with where we are on our partnership. So we are, in fact, okay. I think it's more likely that our next physical training is going to be in Ibadan. I'm not very sure, but let me, if I have a meeting with him and the entire team, I will know where we are starting from. But we have a solid lead of Borno State, which is confirmed. Then I think Nasarawa State is confirmed. So we are going to have physical trainings there. So the
Now we
physical
are in Borno
training,
State, sir.
yes, in Borno State, we are going to give you.
Where exactly in Borno State?
We are going to give you the training center, but it might likely be in the university premises.
Okay, that's good. That's University of Maiduguri, Bama Road.
How about the date?
Yeah?
Have you confirmed the date?
Date? No. We are working with other partner with other company. So, and some of them are profit-making organizations. So, owing to the fact that Big Sun is an NGO, we are not a profit-making organization. So sometimes to get an alignment always takes time, and want it to be on a mutual side so that everybody that have business is looking to make money. So if you are using their facility or any of their things, then you need to pay. So that's why sometimes this alignment with profit-making organizations are not always forthcoming. But we are up to it. We are coming up. So we just need your dedication. Dedication we need to ensure that, okay, if you're doing something, you're certain that the people you're doing it for, is really up to it to take the lead. That's why you're going to go through the leadership training.
Okay. Thank you, sir.
Thank you very much, sir.
Thank you so
I
much,
want to
sir.
say something.
Hello, sir. I'm in the private place. I don't know if I can
Hello.
Hello, sir. Hello, sir.
Razak, what you can do is that you send me a message later, or you can call me. Okay, where you are is very noisy. I don't think you can talk at this time.
So I want to say something, sir.
Okay, secure, right?
Yes, sir.
Okay.
Okay. Thank you. I really appreciate the training. So I attended the training during the week, solar training. So with the training and comparing it with this, and I said this training is up to the standard. So we should take it serious. This is for everybody to take this training serious.
All right. Thank you for that. And then, our training is with the current curriculum. So whatever thing we're teaching you is from the curriculum of the standard institution. And we know what current is, have we? Council
Yes,
for
sir. Yes, sir.
Engineering Regulation. So
I'll also reach you out in your DM, sir.
all
For
right,
some
good.
questions, sir.
Anybody can always reach out to me. Okay, we are together in this. I just want the best for all of us and for the solar industry, because that was the sole essence of this whole thing. Okay, I want the best for you. Thank you. And my DM is always to entertain any question or anything. Okay. Bye.
Thank you, sir.
Bye.
Thank you, boss.
Bye, sir. God bless you, sir.
All right.